Hello everybody, Chris here, and I wanted to go over everything we're going to be discussing in this resource gathering RPG course for the Godot engine. So we have our character with a tool equipped. We can change our tools out simply by clicking on the hotbar icons below. So being able to switch between a axe, a hammer, and a pickaxe. And we can use these tools to harvest the nodes which are relevant. So a pickaxe, of course, being able to swing at a rock node. And you can see that when we harvest it, the pickup rocks will come out. We can gather those as resources. Those get added to the inventory, represented in the top left. If we gather other types of resources, those will be represented up there as well. So to harvest a tree resource, we need a normal axe. Note we're walking across a animated bridge here. So we're setting a lot of this up with tile maps and tile sets. Some of these objects are just dragged into the scene with collision shapes and some scripts added to them, like the trees. So these trees are different from the other ones because they give us a different type of resource. So you can harvest 5 of those, pick them all up, once again being added to the inventory. We're able to walk across these bridges and go to different terrains. And then down here, of course, we can harvest more trees. Another thing I want to point out about how we've set up the animations is that when we swap out a tool, we can use the same animation if it's relevant. So we switch to a different tool, and they can reuse the same animations because what we're changing is the position, rotation, and scale on the node rather than changing the animation on the tool itself. So that also saves in needing to animate some of the frames there. So that's basically the gist of what we're setting up in this project. Tile maps, tile sets, walkable player with animations, a hotbar, and a resource item display, complete with a basic inventory, and a camera that follows the player in this world set up mostly with tile maps and tile sets in the Godot 4 engine. So we'll go through every detail of setting up the scripts, creating our nodes, designing our game level in this series. If you want to pick up the final scripts or the final project complete with the game art, you can find the links in the description below. Or if you prefer, you can just follow along from scratch because we'll be covering all of the code in the videos and you can just follow along there. Hello everybody, Chris here, and in this video I'm going to be showing all of you how to create a resource gathering RPG inside of the Godot engine. So if you've been following my channel, you know I did a similar video with Unity engine as well. So we're going to be recreating more or less the same project now in the Godot engine for those who prefer to use Godot and stuff. So for this tutorial, I'm going to be using my own art pack, Gatherer's Exterior RPG pack. It's not required to follow along, but it does have resource nodes, items you can pick up, tools you can use in order to harvest resource nodes, and a character with a swing and walk animation. That'll make it easier to finish this tutorial. So if you'd like to pick that up, you can find the links to it in the description. I'll also have the finished project at the end of this tutorial for download as well. Once again, though, it's not required. You can basically use whatever art assets you want for the project. So if you are going to be using the art pack, download the art-only.zip version. Since we're not using the Unity engine, we only need the art assets to bring those into Godot. So inside the zip, we have the art folder. So what I'm going to do is bring this into the file system for our Godot project. So to get to the root folder of the Godot file system, find resources, // right click on that and do open in file manager. So this brings us basically to where we have the project set up and we can create other folders we'd want in here. So I'm going to right click and create a new folder and I'm going to call this art. Let's double click into it. And now from whatever zip management tool you're using, whether that's 7-zip or WinRAR, just drag the art folder into the project. So this is now an art folder listed within art. I'm going to rename this to be Gatherer's Exterior so that we know what art pack we have set up inside of the art folder. If you double click into it, then you'll see all of the other folders and the other assets that you can use for your project. So now if we click back into Godot, Godot should automatically recognize all of the files we brought in, and then we'll be good to go. So the first thing I want to show is how you can equip a tool to a character and switch between tools while maintaining the same animations and use them to harvest the different nodes in your game. So let's start our project off by creating the base for our character. So instead of clicking 2D scene, I'm actually going to click other node here. And let's search for character. So we're going to find character body 2D, which as you can see here is a 2D body node for characters moved by script. Sounds like exactly what we want. So let's click create. Next, we can take the name of the node, character body 2D, and rename that to be player so that we know that this is the player character for our game. Now, before we go further, let's actually save this scene inside of our project so that we can reuse it anywhere we need and we don't lose our work. So I'm going to hit Control S to save our player scene. This is the root of our project. So let's create a new folder, and I will call this new folder characters to store all of the characters, whether that's an enemy or a player character inside of our game. Click OK, and let's save player.tscn inside of here. So now in the file system, if you open up the characters folder, you should be able to see our player.tscn scene. And anytime you want to edit it, you can just double click on it and open it up. So our player scene obviously is going to need more than just this character body 2D, which handles the physics. We want to actually be able to show a sprite inside of our character as well. So let's right click on the player node, do add child node, and let's look for sprite 2D. So this sprite 2D node will be the base body of our character. So I'm actually just going to rename with F2, and I'm going to call this sprite 2D node body to be more specific on what it actually is. So now if we open up Art Gatherer's exterior characters, we should be able to find the animations for our characters separated into their own individual sprite sheets. So let's start by taking gather swing down.png, and I'm going to drag this into texture. So as you can see, this has 3 frames of animation, and they look quite blurry right now. So to fix the blurriness for the rest of the game, let's go to Project, Project Settings, go down to Rendering Textures, and where we have Default Texture Filter, change that to Nearest and hit Close. So now the pixel art should render correctly in our game. Next, we want to take these frames and turn them into an animation. So let's right click on player and add another child node, and we're going to look for AnimationPlayer. So let's create that. And this will open up the animation window at the bottom. So click on the animation button, go to new animation, and let's name the first animation. We'll say swing down and click OK. So first we need to slice up the sprite sheet. So I'm going to click on the body node. Let's go to animation. And for H frames, I'm going to set that to 3 because there's 3 frames here. So 3 frames going horizontally, 1, 2, 3, means we change H frames to 3. So now the sprite sheet has been set into 3 separate chunks. And I want to make sure that when this animation starts, that this H frames value is keyframed at the start so that it will automatically be set in this sprite node. So click on the keyframe button, and you'll see this as long as you have the animation window up down here. So click on keyframe and then click create for new tracks. And if we look down in our animation window, you should see the keyframe with H frames set to 3 here. So that means when our animation gets to this point, H frames is going to be set to 3 on our body sprite 2D node. Okay, next, let's click on body again, and let's add in the frames. So we're going to start with frame 0 from our sprite sheet and then add 1 and 2 in. Before we do that, we want to change the snap on our animation to 0.2, since these animations were set up to be 5 frames per second. So 0.2 seconds means you get 5 frames in 1 second. Now that that snapping's done, if we click on the keyframe add button for animation frame, we'll get the confirmation to add a new property and add the key. So hit create. And immediately after that, frame will jump to 1. And you'll see that the snapping of our animation moved to 0.2 seconds. So every 0.2 seconds, it's going to snap, and we can set new keyframes. So to automatically add the second one in, frame is already set to 1. So we want to keyframe that. So just click on add keyframe, and then we'll have frame 2. And we click on this again for our 0.4 seconds part of the animation. So now we have these 3 frames. We're going to change the timing of our animation to be 0.6 seconds. So over here on the right, type in 0.6, and we don't need looping for this animation, so you don't need to toggle this on or anything. But if we hit play, we should be able to see our swing down animation. The last thing we need to make sure is that when this animation is playing, that the right texture is set inside of our animation as well. So go to 0 seconds of our animation and click on the keyframe button next to texture, which will add the texture property to our keyframe track. So let's click create there. And this now means that it will switch to putting this as the active texture in our body so that we're actually showing the right animation. H frames slices it up to the right number of frames. And then these are the frames that we're actually playing. And those should be the 3 things we have to have for our body sprite 2D. The next thing I want to do for this animation is to make it so that we have a tool in the character's hand. So we're going to need to add extra nodes to our player. And we'll actually make this a separate saved scene inside of our project, so we could actually add it to other characters as well. But let's start by right-clicking on player. I'm going to add a child node, Let's look for node 2D. And I'm going to rename this to be, let's say, hand equip, as in the item that we have currently equipped to our character's hand. Now, under the hand equip, I'm going to right click, add a child node, and let's get a sprite 2D. And then let's also right click on hand equip, add a child node, and I'll look for a area 2D node. So this is a node for detection. So we could use this as, let's say, a hitbox. So when our character swings a pickaxe or a hammer or something, it can damage a resource node. Or we could do basically the same thing with a sword if we were trying to attack an enemy later on. So let's create this area 2D under the hand equip. And our area 2D is going to need some kind of collision shape so that it knows where to detect other objects. So I'm going to right click inside of this, add a child node, and then let's look for a collision shape 2D. In inspector for shape, I'm going to change the shape to, let's just say, a rectangle shape for right now. And for the sprite 2D node, let's actually show a tool. So in the Gatherer's exterior pack, I'll open up tools and let's just drag axe copper PNG into the texture there. To make sure that the axe actually renders on top of the area 2D, I'll just drag the area 2D above the sprite 2D. So that's just the default rendering order there. Whatever's in bottom is going to show on top. And this makes it a little bit easier to actually see our axe. Now let's also shrink the area 2D size. So I'm going to go into the area 2D collision shape and let's shrink this to basically match the size and shape of the axe head. So something like right around there should be pretty good for our axe detection area. Okay, so now let's add in animation keyframe values for the tool itself inside of our swing down animation. So we can actually animate multiple sprites at the same time in one animation. So for equip sprite, what I'm going to do here is rather than enabling flip H for the offset, which you can see flips the sprite, but it doesn't actually change the positions of child nodes like the area 2D, which causes us a bit of a position issue. So what I'll do instead is I'll take the equip sprite, we'll go to node 2D in the inspector, turn off the link between scale X and Y, and take the scale X and set that to -1, which is going to flip it from right to left. So we're going to want to keyframe that value inside of our animations. So click on the keyframe button to add the scale property to our track. And now our animation will have the axe facing the left, but also it changes the position of the area 2D, which helps us out. Next, let's position our equip sprite over here to the hand of the character. And I'll add a track for the position as well. And let's lastly do rotation. So create the keyframe for rotation. Now that we have these properties in, if we want to automatically have those update whenever we set it to a new value at a different keyframe or in this existing one, we can click on this REC record button at the top of our 2D window. So auto insert keys when objects are translated, rotated, or scaled. Toggle that on. Now let's go to 0.2 seconds and we can change the values of our scale, rotation, and position, and it will automatically keyframe in the animation for us. So if I just drag the position of our axe up to here, you'll see that the position keyframe is added. I'll hit E to go to rotate mode, and now we can rotate this sprite down like this. Hold control down if you want it to snap to 15-degree increments. And let's get it to be something like there, -180 degrees. I'll hit W to go to move mode, and let's position it into the character's hand once again. Okay, so let's go to 0.4 seconds now, and make sure you're clicking on the equip sprite still. And with record mode enabled, let's go to E for rotate mode and rotate our sprite downwards. I can hold control to snap it to different increments if I want that to be a little more precise. And then let's hit W to go to move mode and move the position of our X down here so that it ends up roughly right in front of where our character is standing. Maybe we even want to go a little further than that. And I can hit E to go to rotate mode. Let's rotate it a little bit over here and just kind of, to keep changing the position. Okay, and something like that looks good. This should be a good hitbox for in front of the character. So we can go with that for right now. Okay, now we want to test our animation. So go to 0 seconds in our animation and hit play. And what you'll see happen is that our X does animate into the correct positions, but in between those keyframes, the position automatically adjusts to a in-between value, which gives us a little bit of a wonky looking animation. What we actually want to occur is that the animation values only change when our keyframes change so that we can sync up the positions with the actual sprite animations of our character. So on the right side of our animation track, you can come down here to where you see these little lines next to scale, position, and rotation. And you want to change the update mode from continuous to discrete. If it's in discrete mode, then the values only change when the keyframes change. So if you do that for all three of them and you hit play, then now the animations are only going to change 3 times at those exact intervals. And now the animations sync up with our pixel art character much more nicely. So because we set up our equip sprite to only change the scale, position, and rotation through our animation, we can now change something out like the tool to a different tool. Like let's drop the hammer in here, hit play, and we play the same animation with a different tool. We could try adding in the pickaxe here, and more or less without changing much else, it's going to function about the same. One thing we could do is just make the collision shape a little bit bigger. So I'll just try to adjust it like that. And now if we change the sprite on the equip to the hammer, then that will work. If we change it to the axe, that works too. And the pickaxe should be a good enough hitbox there as well. So with a little bit of tweaking, we can get one animation to work for different types of tools. And now what we would need to do is just have a script set up so that we can change our tool to a different texture later on and have different tools interact with different objects in the game. For instance, a axe is probably going to harvest trees, but a pickaxe would harvest ore or stone from a rock. Let's make another animation for right now. I'm going to click on Animation New, and let's do Idle Down. Okay, so for idle down here, we want to go to the body, and we're going to change the animation set in the texture here. So let's go to characters, and let's look for the walk down animation. So for our idle, we're just going to use the first frame of walk down. So let's drag that in there. We're going to set the texture, keyframe that in our idle animation track. So let's create that texture. For H frames, there's 4 frames here. So 4 for H frames, keyframe that, hit create, and then keyframe frame 0 in our animation. For this animation, we can just take the duration to, let's say, 0.2 seconds. I'll take snapping and make that 0.2 seconds just for consistency. We can hit play, and that is going to be our animation, where basically the character just stands there. So now we should also keyframe the position of our equip sprite so that when our character is idling down, the sprite is still in the correct position. So let's hit W to move our sprite and position it into where our hand should hold the sprite. So I'm going to keyframe position here. Let's keyframe rotation as well and scale as well. So just to be consistent between all of our animations, we'll just keyframe position, rotation, and scale to something for each of our animations. So when we come into this animation, idle down, the pickaxe or whichever tool we have equipped is going to position itself over here. And we go back to swing down and hit play, and you can see that they have different values for each of those animations. And next, we can also do walk down as an animation. So let's go do new animation walk down. So for walk down, we're going to use the same texture file in the player body. So keyframe texture up here, create that, keyframe the H frames as well. And then let's add in all 4 frames of the animation, keyframe, and then hit that 3 more times. But before that, let's change the snap to 0.2. Okay, and then actually set the value to 0.2 here. Okay, and then frame 1 in the inspector window, keyframe, and then frame 2, we have that, keyframe, and then keyframe. And then that's our 4 frames of animation. So take the duration and change that to 0.8 and toggle looping on. And now we can hit play, and there's our walking animation. So of course, we're going to need to position the pickaxe / tool in the correct spot, depending on where the hand is positioned. So let's go to equip sprite, and then let's keyframe position, hit create or spacebar, rotation, enter, spacebar, and then scale, spacebar as well. So we have those properties in there. Oh, and make sure to change them to discrete mode for all of the animations. It should be discrete and idle down as well, though I don't think that made a difference there, but just for consistency, always make it discrete. Okay, and now we can do the rest of our frames of animation for the equip sprite and walk down. So go to snap 0.2 seconds in, and let's position the tool, W for move mode. Let's get it right around there, 0.4 seconds. Okay, back down, 0.6 seconds, and it should be forward. Okay, so now if we loop our walk animation, It's going to be roughly like that. So we can kind of decide if we want to have some rotation added in here as well as our character kind of bops up and down. I think right now, though, it's okay to just have it just moving a couple pixels with our hand there. I don't think that's too bad. So let's actually just Control S, save our scene, and we have 3 animations set up. Later, of course, we'll do the different directions for left, up, and to the right. Okay, now if we look at our player node, it's had this warning for a while about having no collision shape. So a character body 2D is a physics object, and for it to actually work properly, it needs to have a collision shape to go along with that. So let's right click on player, add child node, collision shape 2D, and then let's actually just add this in. So a new shape in the inspector. You could use a rectangle shape or a capsule shape. I think both will work okay. I will go with capsule since our character is kind of rounded anyway. And then let's take the size of the capsule shape and shrink it down so that it's really just kind of fitting the body, excluding the head. I'll use W to go to move mode, and let's move this down here to the bottom. I'll shrink it a little bit more than that even. Something like that looks good, pretty good, where we have it centered down the middle. It doesn't take up the full size of the head because really the head shouldn't be colliding with anything if we're thinking of things from a top-down game perspective. So that should be okay for a collision shape. We can always shrink it a little bit more later if we need to. So let's hit Control S on our scene and save it. Okay, so for motion mode on our character, I want to change that to floating because we're doing a top-down style. So our character is not going to be affected by gravity. We're just going to be kind of floating around the scene. If we run into a wall, yes, the wall will stop us. But aside from that, we're just kind of walking left, right, up, down with no gravity or really physics acting on our character. So next, let's add a new script to our player. So just click on the new script button. You'll see the template is checked here, basic 2D movement. So we'll start with that and then we'll edit it. So we have our player.gd script being saved in the characters folder. Let's create that. So the default script is set up to be more of a platformer controller. So the first thing I'm going to do is remove the ability to jump and remove gravity from here. So I'm going to cut that out. And down here, add the gravity. Let's remove that as well. For the jump, let's cut that out as well. So we have var direction input.getAccess, and we can either move or we can not move. And then we're going to do move and slide to actually process the movement of our character based on whatever the velocity is set on the character body 2D. For this constant speed value, let's change that to an export variable so that we can customize the speed value in the inspector if we want. So I'm going to replace constant with @export var. I'm going to make speed lowercase, and this will be a type of float. And we can leave it set to the 300 pixels per second still if we want. That's fine. And then we just need to update the speed variable down here. Make sure that the name is referenced the same. So replace the capital speed with lowercase speed for both of those. Okay. And now let's go to 2D view. Then let's hit run current scene up here in the top right-hand corner. And we should be able to see our character. Let's use left and right on the keyboard. And you can see our character does in fact move. WASD doesn't work right now because the default keys are set up to up, down, left, right. But at least we can move left and right. So we want to add in at a bare minimum the ability to move up and down as well. So now to change how our character is going to move, let's take the advice here where they say you should set up some custom actions for your character's movement. So let's go up to the project menu and go to project settings and go to input map. So you can check show built-in actions here to see stuff like the UI accept and UI cancel and left, right, up, down. But let's actually toggle that off and just add in some new custom actions here. So the first action we're going to want to add is going to be left. So type left and enter that. Right, enter, up, enter, down, enter. So these actions are going to correspond with the WASD keys, or really you could choose to use whatever keys you want. But I'm going to hit plus on left, and then I'm going to type the A key on my keyboard, and it will select A from the list of options. So hit OK, and now A is assigned to the left action. So let's do the same thing for right. Add event, D for right, OK. Click on up, W for up. Okay, down, S for down, okay. So now we've set up our movement actions. Let's click on close. Now let's come down here to in the script where we have direction equals input get axis. So we don't want to get one axis now. We actually want to get a vector, which is going to have an X and a right axis. So this will be our X axis, except replace UI left with just left and right with right. But then we also need to add in up and down. So let's do var direction. So let's add a new line here. Var direction equals input dot get vector. And then we need to pass in 4 directions. So we start with horizontal negative, which is left. Okay. And then we do right for horizontal positive. Then we do up for vertical negative. And then we do down for vertical positive. Okay. So let's remove the first line. Okay, and now we have this as a vector 2. If we want, we can specify with a colon vector 2 here that this is supposed to be a vector 2, but that's not required. It should be pretty obvious. So when we would be assigning velocity x, that would be taking a float, not a vector. So what we actually want to set for the velocity is going to be velocity equals direction times speed. And then down here, we can just set the velocity to 0 if the character is not moving. So velocity equals vector2.0. Okay, that should be just fine. Now, the last thing I want to do is strip out any magnitude from this vector that might show up and normalize it to basically have a total value of 1. So when we have the vector, we can type dot normalized. So we can do dot normalized on a vector to make it have a magnitude of 1. Okay, and we can get rid of these comments up here. Well, actually, I'll replace it with move in 4 directions. And if this works, that should probably be all we need to do for getting our character to move around up, down, left, right. So let's go out to our scene, and then let's hit the run current scene button and use WASD to move our character around the scene. So as you can see, we can move just fine now. But obviously, our character scale is really small, being pixel art and all. So let's change our window settings. Let's go up to Project Settings, and go to the General tab, Window, and I'm going to take the scale here on Stretch and change that to 4. Now we click Close, run the scene again, and as you can see, the character is much bigger on the screen now, and that should be a bit more appropriate to what we're looking for. Okay, so now that we have a moving character, it's probably about time that we set up a basic scene for our character to run around in. So let's go up to Scene, New Scene, 2D Scene, and then I'll rename this node to be something like Game Level. Let's hit Control S. Go up one scene, create a folder for levels. So I'll type in level, and let's save gamelevel.tscn inside of there. Okay, next we need our character to actually be in the scene. So in our project, let's drag player.tscn inside of the scene. Just put it anywhere you want it to be. And there we have a working player inside of our scene. We'd probably want something in the scene aside from our player. So let's go to Art, Gatherer's Exterior. Then I'm going to look for something like, let's say, objects, and I'll go to grass. And here we have some rock objects we can add to our scene. So I'll try rock tall 1, and let's just drag it into our scene here. So now we have a rock object inside of our scene. Let's hit play, and you can see that no main scene has ever been defined. But now we can select the current scene, the game level, as our default level to load when the game starts. So select current. And now whenever we hit that play button, this scene will load. So we can move around in the scene. And you can see that the sprite for the rock is there, but we're not really able to interact with it because right now it's just a sprite. So let's click close. Next, let's add a follow camera to the scene. So whenever our player moves around, the camera will go ahead and track the player. So I'm going to right click on game level, add child node, camera 2D. And to make this camera follow the player, we need to right click on the player, add a child node, look for transform, and we're going to do remote transform 2D. So create that. And this remote transform 2D, we can assign that to a camera with the remote path in the inspector. So assign camera 2D. And now this camera 2D is going to follow our player around wherever he is on the scene. So if we hit play, then as our player moves, the camera just stays on top of the player. So it can kind of work like that. Now, we might not want it to always 100% track the player, no matter where the player moves. We can have a drag setting, so the player has to walk away from the center of the screen before the camera starts moving. So let's hit close, and let's try working on that a bit. I'll go to drag. Let's do enable horizontal and vertical, and the left, top, right, and bottom margins of 0.2. We can just leave that as the default. So let's hit play again, and let's see what it looks like with the drag. So now you can see that there's like a dead zone in the center of the screen where the camera won't move until the player kind of gets away from that. So that might look a little bit better than always having the camera move no matter what. Another thing I've noticed is that the character's default speed is way too fast for the game. So let's open the script and change the value from 300 to something like 200 and save that. Now, you don't necessarily always have to edit it in the script. You can change the value in the inspector. Since this was set up as an export variable, it's set up here, and you can customize it. So also in the scene, our rock has no physics body for it. So let's actually add a physics body to the game level. So I'll right click on game level, add child scene, and let's look for a static body 2D. So static body 2D is a physics object which doesn't move unless you change it by script, and it's good for floors and walls, but I think it will also work pretty well for something like a rock, which is never supposed to move in the scene. So let's create that, and I'm going to drag the sprite under it. So for the static body 2D, I'll hit F2 and rename it to be resource node, and let's say rock tall. And we'll come back to adding a custom script to that later so that we can actually harvest resources from it. For the sprite under it, I guess we can just rename it to be sprite 2D as the default, since the parent name kind of takes care of the fact it's a tall rock already. And now to get rid of the warning, let's add a collision shape to the rock. So I'll right click, add a child node. Let's look for collision shape 2D. Under shape in the inspector, choose, let's say capsule shape. Okay, and we can see that shows up here in the top left. So let's click on sprite 2D and actually reset the position to 0, 0. Okay, so now all three of them are stacked on top of each other. I'll take collision shape and move that on top in the order so that the sprite shows on top of it. And let's take the collision shape and have it match our sprite a little better by shrinking in the sides, kind of like that. And maybe I even offset the position by a couple pixels. So you can hit W to go to move mode, and then we can drag the collision shape down. Okay, so next our tall rock has no physics body associated with it. So let's add a physics body in our game level and attach the sprite to it. So I'm going to right click on game level, add child node, and we're going to look for a body. So we can use static body 2D because it's not supposed to move. So use static body 2D create, and then I'll rename the static body to be resource node rock tall. I'll bring the sprite rock tall 1 under it, and then let's right click inside of resource node rock tall and add in a collision shape 2D, which I will make a capsule shape. Now you can see here the position here for the collision shape is resetting to 0, 0, which is very far from where the rock tall is. So let's actually take rock tall 1, go to the transform, and reset the position. So now all three of them are stacked on top of each other. Because this list of nodes is getting a little more complicated, we should really save it as a separate scene. So I'll right click on resource node rock tall, and let's save branch as scene. Let's create a folder here. I'll call it objects. And inside of here, I'll create another folder called resources and click OK. So let's save resource node rock tall into objects resources and hit save. Okay, now let's jump into the scene so that when we're editing it, we're editing the scene saved to our project. So click on the jump into scene button. And in here, we want to take the collision shape and just make it actually make sense for our tall rock. So it should be kind of a circle right around here. So let's shrink this down until we get something like that. I'll hit W to go into move mode, and let's move the collision shape down to right around here. I can hit Q to go back to select mode if we need to stretch it just a little bit wider, maybe W and move it up here a little bit. The advantage of a capsule shape is that you can make it more of a generic oval like an egg if you need it to, rather than just being a regular circle. But in this case, a circle collider would have worked just fine too. So now we have the static body for physics and interactions. We have the collision shape to determine where those collisions should happen. And we have the sprite, which shows the graphics on the screen. For this sprite node, let's actually rename that to be sprite 2D, keeping it more generic here, since the resource node rock tall kind of already says everything we need to know about this node. So let's save this node, go back to the game level, and move our resource rock tall somewhere into the scene. We can also hit Control D to duplicate it and move the second copy up to here, and maybe just duplicate and create a third one, and let's bring that down there. Now let's hit play and test out our scene again. So we want to make sure that the collisions actually happen. So let's move into the rocks, and you can see that now we can't move through the rocks. We do have a visual sorting issue, which we'll take care of in a second here. Basically, the head should never show below the rock like this, but the collisions are happening, which is good. Okay, so to fix our Y sorting, go to the game level, and under canvas item, we want to do sorting and Y sort enabled. So this will take anything under it, any other 2D nodes, and make them sort visually as long as they are parented to the game level. So let's hit play and test out that Y sorting again. So here we're behind the rock, so we show behind it. But if we go to the front of the rock, now you can see that the Y sorting is working correctly. So really easy to get that part working, and it works pretty well. Next, let's jump back into the player and let's finish setting up the animations, and then we'll add an animation tree so that we can switch between idle and run animations, and also switch to the swing animation when we need to. So for animations, let's go to idle down, and I'm going to just duplicate this. So we'll do idle up. And then for that, we take the texture, go to art, gathers exterior characters, find walk up, bring that in here for the texture value. And that should basically be it, actually. So if we bring the cursor back to frame 0, we'll see that the animation updates here. If we hit play, our character's just not moving. Basically what we want, but then the tool we actually want to show in the right hand. So we are going to need to have to move it over here to the right. So let's toggle recording, click on the equip sprite, take the scale value, turn off link between X and Y, and then take the scale X and make that 1. Okay, and that should automatically update here for the scale here. If it didn't, then just change the value manually. So uncheck the link and do 1, 1 for the value for the equip sprite. Okay, now we need to move it over here to the right. So W for move mode and reposition it. Okay, and you can always test by hitting play, just making sure that it's going to be positioned to the right spot. And then in order to get the tool to show behind the character in this case, you might want to add an Z index and keyframe that to, let's say, -1 as the value. So you see, if we make it -1, then now it's going to show behind the character, which looks more correct. And let's add that keyframe in there. So now that will look correct for this animation. But if we switch to something else like idle down, you can see that's still going to have that value of -1. So if we do the ordering this way, then we do need to make sure we reset that on our other animations. So let's go to idle down, and I'm going to take the Z index and make it 0 here and keyframe it there at the start. So let's create and add that. So now on idle down, our pickaxe shows in front of the player, but on idle up, it shows behind. Same thing with swing down. Let's add in the Z index of 0 and keyframe it. So we only need to do this at the start. And then walk down, we will also keyframe the Z index to 0. And make sure that the keyframe values actually snap to 0, 0 here. I'm not sure how that happened, but yeah, we just need to just make sure our animation's working properly and everything's snapped to the right interval. Okay, and if we hit play, then that's looking correct for walk down as well. Okay, so let's keep going. We have idle up. Let's duplicate that and do idle left. So click on the texture keyframe and put in gather walk left as the animation. Okay, and then toggle it to 0 seconds so that we can see where everything's at. And we need to change the position of our equip sprite. Also the scale by the looks of it. So I'll click on scale, toggle off link, and change X to -1. And yeah, whenever you just need the values to update, when you set it manually like that, just toggle it back to 0 seconds by moving the timeline cursor around. Now let's do W for move mode. Let's position our pickaxe over here. So just remember where the right hand is for the animations to make sense. So if the character's facing the left, the right hand is behind the character. So we do want the tool to show behind the character, which -1 Z index value will fix. Okay, so let's duplicate one more time and do idle right. Okay, so change the texture out to gather a walk right. And then we just need to, once again, reposition everything. So take the sprite and let's toggle off the link for scale, change it to 1, 1, keyframe that, hit W to move and position the tool over here right around there. The Z index, we need to reset that to 0. So let's do that and then keyframe it. Okay, and the pickaxe can be right around there. We might actually consider like rotating the pickaxes down on these left-right animations so that it's not right in front of the character's face. So we could hit E to go into rotate mode, rotate it something like this. You can even hold control down if you want to snap it to 15 degrees. W to move it down, and let's move it down there. Yeah, maybe we need to rotate it more. So I'll snap another 15 degrees, move it down with W. Okay, so that should work out pretty well. Just click on the keyframes and make sure it got all of the values. And it did. So let's make the idle left now match that. So go to idle left. So we'll take the rotation of this. I'll hit E, let's rotate it 30 degrees to the left. So that's -30. And then W to kind of position it. So position it like that. So idle right has it there. Idle left has it there. And that should work pretty okay. So now we just need to repeat the steps for our other animations. Swing left, up, right, and walk up, left, and right. So let's start with walk here. So I'll go to walk down. Let's duplicate this. So I will call this actually walk up. So for the texture, we want to change out gather will walk up, put it there. So just like with the idle animations, we're going to need to adjust the position of our equipped sprite here as well. So let's make sure, once again, recording is enabled so that you get the auto keyframing. Let's hit W to go into move mode and position our tool over here to the right. Now, of course, we need to flip its direction as well so that the tool is facing out to the right. So let's go to Z index, and I'm going to change that value to -1 here. Hit enter. To update that, just toggle the timeline to time 0. Okay, let's get the tool further over here to the right. Then we're going to need to reverse the scale as well. So I'm going to turn off the link in the inspector, and let's take the scale to 1:1. Okay, and I'll readjust the timeline to the 0 second there, so we get the tool to adjust its position. Let's move it with W, and let's see. I think for the walk down, we just kind of had it at that standard rotation of 0 degrees. So we'll just do the same thing for walk up as well. Okay, so there's our starting position. Now if we go over to here, we just need to set the next position. Okay, and here we'll have the position set as well, something like there. And then the last position over here to the right. We also need to take the Z index and set that to -1 so that our tool hides behind the character visually. So let's go to the value here in the inspector, put -1, reset the animation, hit play, and let's see how that looks. So that's not bad right there. It's pretty consistent with our walk down animation, just reversing the direction. So we can leave it like that for now. Okay, let's do walk left and walk right now. So I'll go to walk down and duplicate that. Make this walk left. So for the texture of the body, let's take walk left.png and put that in. Okay, and then we can hit play for the animation and see where we're at and what needs to change. So in this case, the tool is going to hide behind the player. So we need to change the Z index to -1 again. And you can really use whatever value you want for the Z index here, as long as it's a negative value or hide behind the player's value of 0. And having it set to something below -1 might actually be preferable, because then you have that in-between value. If you ever need to stack more than 2 sprites on top of each other, it won't be an issue for this tutorial. But just keep that in mind, that this is an ordering thing, and you can have multiple objects, not just 2 or 1 object. So anyway, we need to reposition the tool. So I'm going to hit W to go to move mode. Let's put this over in front of where the player should be there. And I can hit play for the animation to get that Z index value to update. Okay, now we just need to update the position of the tool to wherever the player's hand is. So it looks okay at 0 seconds. Let's jump to the 2.2 seconds frame. And let's move it back here. Since the right hand is going to mirror opposite the left hand, let's go to 0.4. Okay, and we actually are going to want the same value as here at 0 seconds. So that's -6 and 3. I can just manually type that in for consistency. Okay, -6, 3. And then let's go to the final frame here at 0.6 seconds and position it there as well. So now if we hit play, there's our walk left animation. And we can duplicate that as well for a walk right animation. So for walk right, let's change the texture for the right texture, of course. And we're going to need to reverse the scale on the pickaxe. So let's toggle off the link and make the value 1:1. Okay, so now it's facing the right. Move the position of the tool to right around here for the first frame, and let's keep going forward. So here we need to move the tool right around here. The next one, same position as the first frame, and let's see if those values match. You can, of course, just manually change the value. 7 for the pixel X, and then the last frame as well. We'll just go right around here. Okay, let's hit play for this, and not quite right. So at frame 0, let's change the Z index back to 0 or a positive value so that the pickaxe is going to show in front. Okay, and then we just need to position it on each of the frames to make sense. So right around there, here we can move it down, and there we can move it there as well. But for our idle frames, I believe we gave it a rotational value. Let's see, idle right, idle left. So yeah, 30 degrees there. And we would want that to probably be the case here for idle left as well. So I'm going to put -30 here for the rotation on idle left. And let's try to make it consistent across our animations. So that'll be our idle left, our idle right. And let's go to walk left and set the rotation here to -30. And let's see, do we need to change the position of the pickaxe more? Not too much, but maybe a little bit. Just update it on each frame till it looks good to you. Okay, and then let's go to walk right. Let's set the rotation to 30 degrees positive. Okay, and here we're going to need to reposition things. So let's move the pickaxe. Next frame, move the pickaxe. And here, move the pickaxe. And put the pickaxe there. So there's our walk right. Looks pretty okay. Walk left. All right. Walk up. Walk down. And of course, we have the idle animations. Okay, so basically we just need to repeat the same steps with swing up, down, left, right. So it's going to be very, very similar here. Let's duplicate the swing down animation to make swing up. And then let's take the texture and put our swing up animation in the texture slot. Of course, here we're going to need to make the Z index negative. We're also going to need to reverse the scale on X. So scale to 1, 1. Okay, let's see where we're at. And let's position the tool over here to the right. And then swing up. Still going to need to take that position over to around about here. And then finally, this frame is going to be a little bit trickier. We need to first set the rotation to something good. So let's, yeah, I think if the hand's right around there, then this would probably be a good rotation. So let's get the rotation, maybe something like that, then move it up here. Maybe it needs to rotate a little bit more to the left. Yeah, okay, that looks okay. So it's hard to see the pickaxe if it's even visible at all, but we can definitely see that the hitbox is there. So maybe we just position it for the sake of the hitbox right there in the middle. All right, and let's see, our second frame is okay. Let's hit play on this and see if that's going to work for us. The second frame, I think, needs more of a rotation back. So I'm going to put it like that. Let's move here. Maybe that's too much. Just kind of tweak it as you want. First frame, yeah, we should rotate that as well. So maybe it can be here, and then we go further back, and then we go forward. Let's try hitting play. Okay, maybe too much rotation initially. Let's put it like that, hit play. And yeah, I think we can work with that. We can always come back to this later if we need to tweak it. So let's duplicate swing down again, and we'll make that swing left. So of course we're changing the texture out. So let's get the swing left animation, pop that in there. And in this case, the hand is behind. So we want the Z index to be behind as well. So I'll set -5 here. And then let's position. So here, let's position the pickaxe. Let's rotate it. Okay. So right around there. And then the next frame, let's rotate it. Oh, we want it to actually rotate back. So let's put it right there. And then the final frame, let's rotate it forward so that it hits the ground in front of us. And something like that could be pretty okay. So let's hit play. Okay, and that's looking all right. So let's duplicate this again for swing right. So swing right. Change the texture out to the swing right texture. We're going to need to reverse the scale. So scale 1, 1. Then let's rotate it and position it in the character's hand. Go to the next frame, rotate it backwards for the swing, and position it in the hand. And the final frame, rotate it forward so that it hits the ground, and then position it in the hand. Okay, maybe we overshot that by 15 degrees, so right around there. Okay, so let's hit play for our swing right. Okay, let's test our swing left. Those are looking all right for right now. So basically, we have all of the 12 animations set up here. What we're going to need next is a animation tree. So right click on player and add a child node, animation tree. In our animation tree, in the inspector, we're going to go to tree root, click on the drop down and do state machine. Next, be sure to set up the animation player and the inspector for animation tree. So assign the animation player. So next we can right click on the graph and add in 3 blend space 2Ds for our 3 sets of animations. So the first one is going to be idle, and then we'll right click blend space 2D and rename this to be move or run. Or let's see, what do we actually call it? Walk. So let's make it walk for consistency. And then right click blend space, and we'll rename this to be swing. So when our animation tree starts, we want to start off in the idle animation, and then we want to go to the walk animation if our character is moving, or back to idle if our character is not moving. We also want to be able to go to our swing animation if the swing button is pressed. So let's create a connection to swing, and we'll create a connection back also to idle or walk. So walk to swing and swing to walk. For controlling the logic here, you can create a purely code-based state machine that will change the animations for you. Or we can also set up auto advanced conditions. So these conditions basically encode. We just set something like idle when we want to switch back to idle as a Boolean, or is walking if we want to switch back to walk. And we can have a condition like swing pressed when we want to transition to the swing animations. So you can have the logic actually occur inside of the animation tree. And that's what we're going to do for this character's player logic. So for going back from the swing state, let's change the switch to at end. And the mode is going to be auto. And the condition we can set is moving. For connecting back from swing to idle, let's do something similar. Let's change the switch mode to at end and the condition auto. And we'll say the condition is idle. For going to the swing animation, let's set up a condition, which is going to be swing. And I'll set that for both of the connections between walk and swing, whether we're in the idle state or we're in the swing state. For idle to switch to walk, we have to set the condition is moving. And for walk to go to idle, we'll set up the condition idle. Now you would think that having a condition is moving, if you wanted to switch back to idle, you would just have not is moving here. But as far as I've tested, that doesn't work. You have to have separate Boolean conditions for each of them. You can't just reverse a Boolean condition here. So we have to have 2 separate variables, which is a little annoying, but it shouldn't really be a problem. Okay, so anyway, to go quickly over it, idle to swing uses auto swing condition. Walk to swing uses swing condition. Swing to walk is moving is true. Swing to idle is true, and idle to walk is moving is true, and walk to idle is true. And the only other thing is that for the swing to return, it has to wait until it's at the end of its animation in order to exit its animation. Okay, so let's go into the player script and let's set up some basic code to set those animation parameters. So if we're going to be changing the animation tree parameters, then let's get access to the animation tree. On ready var animation tree is the type animation tree, and we're going to say equal to $animation tree, which means we go in the hierarchy, we find the node named animation tree, and we assign it to this variable animation tree when the script starts on ready. So basically now we can set parameters on animation tree. So let's make a new function, and we'll say update animation parameters. So if we want to set those parameters up, we can go to the inspector of the animation tree, expand parameters, and you'll see those conditions that we typed in are actually going to appear here. Okay, so now to actually set these parameters, we have the parameters set up inside of our little animation tree. If you look at the inspector and you expand down to parameters, conditions, you'll have these Booleans that we set up, idle is moving and swing. So if you right click on these, you can copy the property path. So if we go into the code and hit Control V, you'll see the path appears with parameters / conditions and then the name of the condition. To actually set it, let's delete that for a second and type in animation tree, which refers to the animation tree node that we are referencing up here at the top. And then in square brackets, put in parentheses, and then Control V to paste in the property that we're trying to set. So if we reference animation tree and then the path to the property, that means we're setting this Boolean value here. So for this value, we'll set it to true if a certain condition is met. And then the condition we'll use is going to be if velocity is equal to vector2.0. Okay, basically we're not moving, then idle is going to be set to true. And also at the same time, we can set is moving to false. And also for the if, it's 2 equal signs to compare values. We're not assigning them. So let's also set is moving to false here. So I'm going to right click on is moving, copy the property path, and let's do animation tree, and then in square brackets parentheses, Control V, paste in the condition, and we'll set that to false. Okay, so otherwise, if the velocity is not 0, then we are moving and we're not idling. So let's take Control C, Control V, paste them down here, and just reverse the true to false and the false to true. Okay, so that handles those. For the swing animation, we need this to trigger if the swing button was just pressed down. Right now, we don't actually have a swing key. So let's go up to project settings, input map, and let's add a new action. So this will be, I guess we'll say it's the use action. So we're using whatever tool we have in the hand. And then let's add a key to this. I'll use F on the keyboard. So just press F and then hit OK. And now F is going to use our tool. So let's close that. Okay, so now we can add the check for if the use action is pressed or if it is not into update animation parameters. So let's check if input, and this is kind of a global object you can reference. So you don't need to set it up in the inspector with an export variable or anything. So we're checking if action just pressed, and the action we're looking for is the use action. So put the string for that. So if the use action is just pressed, then we'll say animation tree, and then we need to put in the parameter path. So right click on swing in the inspector, copy property path, and paste it in. So if use was just pressed, then swing is going to be true. Otherwise, we'll say that swing is false. Now this is like a pretty simple way of doing it. We could also like have a timer where after 0.25 seconds of a button being pressed, we would still say that swing is true. But this should at least get us going for getting these conditions to be set. Now, one thing I do want to make sure is that the animation tree is actually active when our player starts. So we can add a ready function _ready. And when that happens, we can say animation tree.active is true. So when our script starts, the animation tree will be turned on to active, and we'll make sure that it's actually running. So now for these animation parameters to actually update, we still need to call update animation parameters sometime in our script. So we could use the normal process function for that, I think. So let's do function _process delta, and then just do update animation parameters. So let's go ahead and hit play and see if anything actually happens when we move around. So as you can see, visually speaking, nothing's happening yet. So one way we can check why that might be occurring is going to the scene view while the game's running and click on remote. So in remote view, we're looking at the currently open game, and we can drill down to the game level and look at the animation tree of our player. So if we click on that, you'll see the conditions being set here. If I start moving, is moving actually gets set to true. And if we stop moving, idle is set to true. So the conditions are working, but the animations are not yet. And the reason is that we simply haven't set up the animations inside of our blend spaces. So exit the game and go back to the animation tree and take a look at the animation state machine here. And we need to open up each of these blend states or blend spaces and edit them. So inside of a blend space, we have a 2D graph, and the animation tree will automatically select which animation to play based on how close to the value of the nearest animation that we happen to be. So if you click over here to create points, that's how you add an animation to the blend space. So click on create points, and then I'm going to click on the far left in the center and then add a animation, and we're looking for idle left. So that is going to be at position 0. So that's going to be at position 0 for Y and -1 for X. Now we can go down here for the idle right. Let's go to the far right over here, left click, add animation, idle right. For the top and bottom animations, because I want left and right to be prioritized, I'm going to change the max for the Y to 1.1 and the min for Y to -1.1. So basically, if we press two directions at once, it'll end up coming closer to the left than it would to the top if our input is somewhere up here, because we're putting the Y value further away than the X value. Anyway, let's go to the top here, left click, add animation, idle up. And then down here at the bottom, left click, add animation, idle down. So left click on each point and make sure their values are correct. So up here, this one's 0, 1.1, that's correct. The bottom one is -1. So we want to pull that further down to be -1.1. And then on the far right, we have 1, 0. And on the far left, we have -1, 0. So now we set up the other blend spaces just like this. So go to the walk blend space, and we're going to put 1.1 up here at the top, -1.1 at the bottom for the Y values. Let's add in the animations with create points, left click, add animation. So we want walk left. Over here on the right is walk right. And then at the bottom, walk down. And at the top, walk up. Okay, let's go back to the root. Do the same thing for swing. So set the Y max, Y min to 1.1 and -1.1. Create points, add in the animations. So walk up, walk down, walk right. And then over here is going to be walk left. Okay, now these blend spaces, how do you set the X, Y values inside of them? So it's very similar to how we set up the animation parameters. If we click on animation tree, you'll see that there are blend positions for the idle, swing, and walk blend spaces. So we simply need to set the blend position for each of those as we update our character script. And how we're going to do that is we get the direction that our character is moving, and we set the blend position to that normalized vector direction. So right click on idle blend position, copy property path. We're just going to come in here to update animation parameters. So we'll do animation underscore tree, square brackets, quotation marks, paste in the path to the blend position, and we're going to set that to the input direction. So up here in physics process, we were getting that direction as a local variable. Let's actually make this a script wide variable. So I'm going to remove the var here. Then I'm going to go up to the top and type in var direction is a type vector2. It'll default to vector2.0 before we start doing input. And we're going to update it every time in this physics processor. We do also need to remove this typing of the variable, since that's now up here at the top. And once you do that, it should go away. So we're setting this variable whenever we update our physics process now. And this is already a normalized vector. So we just need to take the direction and set the blend position equal to that. So equals direction. And we need to do that 3 times for swing and walk as well. So let's copy this, paste it. And for the parameters, we can just type in here, swing. And down here, we'll do walk. So save that. Whenever the direction is updated, we're basically also going to update the blend position for all 3 of these blend spaces. So if we hit play now, we can see that the animations do change, but it doesn't entirely appear to be correct here. So let's check the animation tree and make sure that everything's set up correctly. So in animation tree, let's edit the idle blend space, and let's look at each of these nodes. So down here is idle down, idle up, idle left, and idle right. Okay, and let's check walk. So we have walk up, walk down, and this one should be down here to -1.1. Okay, up there is +1.1. Over here is walk right, walk left. I think we actually need to inverse the walk up and the walk down, since up is actually down on the y-axis. So this should be walk down, and down here, this should be walk up. So you can just change that in the inspector. Okay, let's do that for all of them. This should be idle down, and this should be idle up, and then swing. This should be swing down, and then up here should be swing up at the bottom. Oh yeah, of course. Also for the blend, you want to set that to discrete. We're not trying to blend between the values here. We're trying to have it, once again, like the AnimationPlayer animations. We're trying to instantly jump to each of these values. So make sure that your blend spaces are set to discrete mode. That's the other problem that's occurring right here. So discrete, and the walk should be discrete as well. Okay, let's hit play again and see if that's any better. So left, down, right, up. Okay, the walk animations are switching correctly. And whenever we let go, we're actually switching back to facing the left on the direction. And that's because it's setting the direction to vector2.0. So as a condition for setting the direction, we should actually put in here if direction does not equal vector2.0. So if we don't have any input, then we shouldn't update the direction parameters for the blend positions. So now if we hit play and we do up, down, left, right, that should clear up the idle animations. So that is looking much more correct here. Another minor issue we need to clean up is that when we press the F key to do the swing, but we're facing left and right, it actually plays the walk animation, but up and down work fine. That's simply because I messed up and I set the walk animation inside of swing instead of the swing animations. So if we click on the left point over here, we can see the animation is set to walk left. That should of course be swing left. And over here on the right, it's set to walk right, which it should be swing right. Okay, now with that, if we go in here, we can test all 4 directions: swing left, swing right, swing down, swing up. Okay, so the animations for our character are pretty much working correctly. One thing I want to change though is that the character moves way too fast. So we're probably going to slow him down by at least half. So let's jump into the player script. And I'll pull this down here. Let's go to the top and I'll make his base speed 100. Let's try that. Make sure it updates in the inspector as well, since this is an export variable. Let's hit play and test that out one more time. Okay, yeah, this seems much more like an appropriate speed for the character. We could even slow it down a little bit further and make it something like 80, but I think that this is pretty good for testing. Now what we need to do is that when we swing our pickaxe, if our area 2D comes into contact with our resource nodes, such as the rock, that we want to actually harvest materials from the rock. So on our hand equip node, we're going to want to create a new script that uses the area 2D and detects resource nodes when it comes into contact with them. So let's take the hand equip node 2D. I'll click the add script button. And let's create that in characters/handequip.gd. Okay, so inside of here, on ready, we're going to want to get access to our area 2D. So at on ready var, let's call this variable something like equip hitbox, which is of course going to be a type of area 2D. And we'll look for $area 2D to find the area 2D under the script as a node we can use. Okay, so in our hand equip script, I'm going to get rid of all this boilerplate code except the extends node 2D part. I'm going to click on area 2D here. Let's go to the node tab, which is next to inspector in the top right. And we want to choose body entered here. So when a physics body enters the area, we'll check if it's a resource node type. And if so, we'll run the harvest function on the resource node and get some materials out of it. So let's double click on body entered here. And we're going to connect it to the hand equip script. So we should see this new function come up here when you hit connect, and you can click on area 2D and see where we have the signals connected to. And you can double click to actually jump to the function inside of the script if you ever need to. So we're going to check if the type of body that entered was a resource node. So let's go over to the resource node scene, and we want to attach a new script to this resource node. So I'm going to click on the add button for a new script. I'll call this script resource node.gd because we'll use it for other types of nodes, not just the rock. So let's create that, and we'll give it a class name so that we can reference it by its class name. So class name is going to be resource node. We'll get rid of this extra code down here. And just to give it something, let's give it a export var, and let's call it starting resources as a integer. And we could default this to something like, let's just say 1. So by default, a resource node will have 1 resource. And later, when we run out of resources, we'll remove the node from the scene. So if we click on resource node here and go to inspector, we can see our starting resources value. So to go along with the starting resources, we'll have another variable, current resources, which is also going to be of type int. And when our script starts, so function ready, we'll take current resources and set that equal to starting resources. So basically, when we add a resource node to the scene, whether that's when the level loads or any other time we instantiate it, we're going to start off its resource count with the starting resources for this node. Okay, so we'll come back to this script and add more stuff to it later. Let's go to the player node and jump into the hand equip script. So inside of this on area 2D body entered, we want to check if the body is of type resource node. So we can check here if body is resource node, and we can do this by specifying the class name because we actually created the class name in this script. So resource node is something we can reference. And if the body is of type resource node, then we want to harvest from the resource. So when any body enters our hand equip area 2D for colliding with resource nodes, we want to check if the body is of type resource node. So we can do that by doing if body is resource node. So if the body is a resource node, then we can call any functions from the resource node class on it. So we can do, let's say, body.harvest, and then we'll give it a harvest amount. So when the item equipped to our hand comes into contact with a resource node, we want to check if the tool is capable of actually harvesting from that resource node. So in order to do that, we also need to know what kind of tool or weapon or whatever we have in the hand is actually equipped to our character's hand. So let's add a export var up here, and we could say equipped item. So what we're going to do with these equipped item resources is that when we're in game, we're going to change it to whatever the texture of the tool we currently have equipped to the hand is. So whenever we change the equipped item up here, basically we're updating it across our game, and then we'll be able to use the right tool to harvest the right nodes. Now, I also thought about it for a while, and we can go a step further than this by also making it so that some of that code will run in the editor. So when we change the equipped item in the editor, we can also update the texture immediately. But in order to do that, we would actually have to have the script attached to the equip sprite node. But looking through our animations, all of the properties that we're changing are already on that equip sprite texture. So if we look through here, there's actually no real need for the hand equip node, at least currently. So we can actually just move the script to the equip sprite node, make it extend from a sprite 2D, and then we'll be able to write that code that can update the texture inside of the editor as well. So that will just be one way we can actually make it a little bit better. So what I'm going to do here is take the equip sprite node and just move it outside of the hand equip node. But I'm going to have the animation window open here so that I can just watch and make sure that moving things around doesn't destroy the animation setup here. I think in the past it might have caused some problems, but now let's go ahead and move Equip Sprite up here. And you'll see that Equip Sprite still shows up there, even though we moved everything up. So it's not at the same position, but it's still being referenced by name. So if we hit play here, our animation still works completely. You can see that the hand equip node, we didn't really need it for anything. So let's take this script, the hand equip, and I'm going to, let's move it to the equip sprite. So you can just drag and drop from the code editor right here, drop it in there. And then let's just rename this equip sprite to be hand equip. First, I'm going to delete the hand equip node. So let's get rid of that. And then up here, I'm going to rename this to be hand equip. Once again, having the animation window open to make sure that it handles the renaming of things there. So once again, in the past, like Godot 3, I think that when you rename stuff like that, it would actually break your animations, but now it seems to handle things really nicely and keep up with the new naming of the nodes. So that's super nice. So what we want to be able to do now with our hand equip node is to be able to set our resource here. So right now we can drop any resource into this node, but that's not what we want. We want to create a custom resource, which is a different type of script than a node script, because it is not going to attach to a node in your scene. It's actually going to be kind of a class you can create objects from, and those objects sit inside of your project rather than inside of your scenes as an attached script. So you could almost think of it as a scene you can instantiate, except instead of that, it's just a instead of a scene, it's just a data object. So I have an items folder created in my project. I'm not sure if I created that earlier on screen or not, but create a folder for items, and then we can right click into here and do a new script, and we're going to inherit from resource this time. And what we'll say here is equipable item .gd. So let's create that and double click on the script. So we extend resource here. You can think of this more as a data object rather than a script which enhances what a node can do. So it's not going to have the process functions or anything like that. If you're used to Unity, it's very similar to a scriptable object. So for our resource here, I want to give it a class name so we can be very specific about what kind of item can be equipped to the hand. So let's give it class name equipable item. So anything that is equipable, whether that's a tool or a weapon, will inherit from this. Okay, and then we can give it some data fields. So I'm going to do @export var, and let's start with texture of the equipped item. And this is going to be a texture 2D. Okay, and maybe we also want a display name. So I'll do @export var display name, and that'll be a string. So the reason you might have a display name variable is that how it actually shows up in game, how you want the text to show whenever you reference the item could be different than how you have the name of the resource saved into your project. You might have like underscores here, but that would look ugly in game. So having a custom string field for that can be a little helpful. Okay, so now just save that file. And now if we right click on the items folder, we can go to new resource and look for the type we just created, equipable item. So it extends resource. It's equipable item from the equipable item.gd script. So double click on that to create it. And you'll see that this new resource saves as a .tres file. So it's kind of similar to saving a node scene into your project. So you can use it across your game, except instead of instancing it, you're just referencing this store of data. So let's give it a name. We can just give it test item for right now. Our actual tools are going to have another class that will build on top of equipable item and have some extra stuff attached to it. But let's just create a test item for now. Hit save. Okay, so if we double click on the test item.tres, you can see in the inspector our display name and texture for this resource. So for the display name, I'll just say test item. And for the texture, well, first let's look at 2D view. Let's use something different than the pickaxe that's here standard. I'll go to tools and let's use the hammer.png. So hammercopper.png, just drag that into the texture slot. Okay, so now you can kind of see how this is setting up. We're giving details about what an item in our game actually is. And then whenever we need to equip it, we have these data fields we can use. So let's save everything and click on hand equip. And we could actually drag this equipped item in right now. So if we go down to items, you can see we can drag test item.tres into this field. And when we do that, nothing's actually going to happen because right now our script is not set up to do anything with it. It's just a equipped item. And right now it's still set to resource. So we could have used any resource. The equipable item is a type of resource, but there are other resource objects. Let's be specific now and change this to equipable item. So now by specifying that class name, only an equipable item can fit this field. So other types of resources don't qualify. And that is handy for managing things to make sure we have the right items actually equipped to the fields that allow them. Now we can reset this field and drag it in again to show that we can still set that there. I guess we could do another test. I'll right click here, do new resource, and just do a normal resource here. So let's create that. I'll just save that. And then let's see if we can drag that into the field. We shouldn't be able to. So I'll drag new resource.tres into here, and you can see it doesn't qualify anymore. So it keeps the resources that don't qualify out. Okay, let's delete that new resource. We'll never need that. And now we want to make it so that when we set a new equipped item, we actually update our texture on our Sprite 2D node, which is the hand equip node now. So if we go to the end of this export line and add a colon, then we can add setter and getter functions to this property field. So we want a set. And when we do a set function, we're going to need the new equipped item as a parameter. So new or next item. So as the parameter, I'll type in, let's say, next equipped. Okay, give it a colon, new line, and now we can actually write the code. So when we set a new equipped item, what do we want to happen? The first obvious thing is that we want to take the equipped item field and set that to the next equipped. So the next equipped is the new item coming in, and the equipped item is the field that is set in our script. And then the equipped item is the field set in our script. So after we change the equipped item, this field in here, we want to update the texture as well. So we're going to take the texture, and remember this is a Sprite 2D node now. Oh, well, it should be a Sprite 2D node, but we haven't changed the extend up here. So change this to Sprite 2D. Okay, and now there should be a texture field. If you want to see all the fields that are attached, you could write it like this, self dot, let's say texture, and then it'll automatically know where we're dealing with a Sprite 2D node. So we should be able to access this texture property. So let's do self.texture, and then we'll set that equal to, we could do the equipped item or the next equipped. I'm going to do the equipped item because this will also verify that we've set it properly. So equipped item dot texture. So that's a field that we set up in our resource script, the equipped item. So just grabbing this field here, and then we're going to set that to the texture. So this part will actually already work in game. If we go to 2D view, you can see in the editor we have this pickaxe, but if we hit play, well, the setter function is going to get called, so we switch to the hammer already. And you can see, because of the way we set up the animations, it still works with this tool, because we're just changing the position, scale, and rotation on the node. So it's going to basically work with any tool we equip. It's going to function the same way for those animations. Now, how do we get it to work in the editor? Well, if we go up to the top, we can write this annotation at tool, which means that your code is going to run in the editor as well as in the game. Now, you can specify, as we'll do later on, that certain code will only work in the in-game. And you can also specify if code will work in the editor. But by default, if you have this at tool, it's going to run in both. So for the tool scripts to work, what you need to do is close the scene and then reopen it. So let's go ahead and reopen the player.tscn scene, and you'll see that now the tool has been updated to the hammer texture from our test item. So that basically means that whenever our script loads, the set function is going to be called, and whatever item we have equipped, we're going to grab the texture from it. So this works both in-game and in the editor. So if we go hit play, well, you can see, of course, that we have that tool equipped before. Now, that is now set in the editor by default, but you could see before we added the add tool that was working. So, yep, we don't need to do anything like on ready to set this. Now, something I do want to kind of test for myself here is if we can have this tool script go ahead and, let's say, update another sprite. So I'm going to add a Sprite 2D node as a test, and let's put it under hand equip. And then I'm just going to get that as a onReady var. Or, no, I guess let's make it a @export var. So @export var Sprite 2D, which is a type of Sprite 2D. And this will be equal to, well, no, we're going to set that in the editor, sorry. Okay, so @export var Sprite 2D, we'll assign that to the Sprite 2D node here. And what I want to do is take the Sprite 2D.texture and also set that to the next equipped.texture. So let's see if this will run in the editor. I'm going to grab this node, hit W to move it out, and let's come out here. So I'll save the node, and let's close the player.tscn. Yep, save and close, and then reopen it. And let's see. Invalid set index texture on base nil. So did we set the Sprite 2D node? Yeah, we did. Yeah, so I thought it might actually work like that, where you can't really access other nodes. They do specify in the documentation right here, this bit, code from other nodes doesn't run in the editor. Your access to other nodes is limited. So basically, if you want to add tool script to work, then it seems like you're going to need to attach that to the node where you're actually changing the texture files. So that's why I changed it earlier by removing the node 2D and then just moving the script into the Sprite node. Okay, worth testing. So let's get rid of that and this bit right here and just get back to what we had before. But what's important is that our equipped item thing is actually working here. So anything else we need to set up whenever we change the equipped item, we'll just add to this setter function. So for instance, in our equipped item, if we're like setting the attack damage, then we do something like attack damage equals whatever's in the equipped item dot attack damage. And that's how we'll keep our scripts updated with whatever item we have equipped. Okay, so the next thing we'd probably want to know with our equipped items is what type of equipped item are they actually? So we could make that typing another field under the equipped item, or we can make the typing tied to a class specifically. So we can extend the equipped item class and let's say make like a tool class or a pickaxe class. And then inside of that class, we'll set up a function for when the body enters our area 2D, we interact with a specific type of node, such as a rock, and then we'll be able to harvest from that node. Okay, so now let's go to items and create our new script. We're going to inherit from equipable item with 1p. And let's start with something like a harvesting tool.gd script. The reason for this is that there'll be multiple tools like pickaxes and hammers and maybe like a shovel later on, which are all going to harvest from different types of nodes. So a lot of the code we can just rewrite. There's a lot of the code we can just write here inside harvesting tool.gd. We might not even technically need to create separate scripts for a pickaxe or a hammer. So let's start with this, create, and then we can edit our harvesting tool.gd. So every harvesting tool is going to have a harvest function, which is going to take a resource node and it's going to do something with it. We'll pass for right now. I guess we'll add something like a damage variable at the top. We could call it damage, or we could call it like amount to harvest. So let's say at export var, I'll say min damage, and let's make that an int and default it to 1. And then at export var max damage, and we'll make that an int and default it, let's say, to 1 as well. So when we actually harvest, we can randomly generate between these two values to make it a little bit more interesting. So sometimes when we harvest a node, we get 1 ore or wood or whatever, and then sometimes we'd get more up to the maximum amount. Depends on exactly which tool we have equipped. Okay, so let's save that, and then we'll create a new harvesting item. So let's do new resource. So we're looking for a, okay, we haven't added the class name. So back out of that, class name, harvesting tool. Okay, now let's right click, new resource, harvesting. We got harvesting tool.gd. And let's create this as copper pickaxe .tres. Yeah, okay, we can start with that for now. So if we click on our harvesting pickaxe, we can see we have the display name. So we know this is a copper pickaxe, so we're gonna do copper pickaxe. And then we gotta set the texture. So under tools, we'll drag in the pickaxe copper here. And then our min damage, max damage, we'll leave that set to 1. Now for a second, let's jump back over to the hand equip script. So whenever our area 2D has a collision with a body, then what we'll basically do is we'll check if the equipped item actually has a function to interact with a body. So let's do something like if equipped item dot has method, and let's say something like interact with body here as the name of the method. So doing it this way, we don't necessarily check the exact class of the equipped item, but we just see that whatever script we have attached to it, it actually has this function. So we just need to make sure that if we're creating different types of tools or weapons, that anything that is going to interact with a body, deal damage or whatever, actually has this function here. So just a different way of doing things. So if the equipped item has the function, then we're going to run it. So equipped item dot interact with body, and we're going to pass in the body. Okay, and then that basically passes everything over into our equipped item script. So this basically passes the flow into whatever kind of equipable item we have that is going to use the interact with body function. So a harvesting tool is going to interact with bodies. So let's go to harvesting tool, and yeah, I guess we'll write that function down here. Function interact with body. It's going to take a body. Okay, and what we're going to check on the body is if it is a resource node. So let's go back to resource node up here. So we do have the class name resource node, so we'll check if the body has that. So in harvesting tool, we'll check if body is resource node, then we can continue. And I think for right now, it would be a good time to test print interact with resource node. Okay, so we can basically run the game and see if that will actually work there. So let's hit play and let's walk around and watch the output console. Okay, so let's try swinging at it. Okay, so currently it's not doing anything. Let's see. In the player, we have this test item. The test item is still an equipped item. It's not what we actually want. It's not a harvesting tool. So you can see that the test item, which is just an equipped item, doesn't actually do anything when it interacts with a body. Let's try with the copper pickaxe. Drop that in there so it updates here. Let's hit play, and let's go walk towards that resource node and see if we get the interaction to occur. I'll swing at it. Still technically doing nothing. All right, so let's kind of debug that a little bit. I'll figure out what's going on. So first, let's jump into equipped item and let's see if we're getting here. Let's even see if the area 2D body entered is running at all. And then let's add in harvesting tool, add this little bit here where we'll see that if we're checking if it's a resource node. So if we hit play, we can come down here and see that nothing's still happening. And I just noticed what's actually going on. So our area 2D isn't actually connected to our hand equip. Of course, that would be because we changed nodes. So we need to go to the node area 2D next to the inspector, and we need to take body entered, and we need to reconnect that to the hand equip node. So connect that there. Okay, it's going to use the same function, but now the signal is actually connected. So signals can be connected like this, or it can be connected in code. Now let's hit play and see how far we get with our interaction. Okay, so we moved there, and the body is probably going to be something like itself. So let's see, what item is that actually? So our area already interacted with the body, probably the character's body. So we're just going to pass from there, and then we can continue. Okay, so now we're going to check if the body is of a type resource node. So it is passing into harvesting tool. So let's continue from there. And let's see, did we get the output? We did not, because it checked that the body was not of type resource node. So let's watch the output still, and I'll go back to the game, and let's actually walk towards those resource nodes. So when we get here, we get interact with resource node. Up here, interact with resource node. And here, interact with resource node. Now, of course, we don't want the interaction to occur all the time. We only want it when we're actually swinging the pickaxe. So that'll be something we set up in a minute. But so far, we actually are getting those interactions, which is good. So next, if we know that we are interacting with a resource node, we want to check what type of resource node the body is, or what tools it can be harvested with. So to do that, let's create some classifications for what type of resource node our rock actually is. So obviously we want to say it's a rock. So what we can do is create a resource node script, which will identify our resource node as a rock, and then create a field, drag it in here, say that this resource node is a rock. Okay, so now in our resource types folder, let's right click, new script. So let's create the script for our type. And what we're going to call it is something like type of, I guess we'll just say node type dot gd. Okay, yeah, we can do that. And or maybe resource node type actually. So resource underscore node underscore type. Okay, now we'll double click into there. Let's do class name here, which is going to be resource node type. Save that. And then we can right click in our types folder and start actually creating those resources. So new resource, resource node type. So the first type we'll create in here will just be a mineable type. So this could be anything from a rock to a ore vein, or just anything you can swing a pickaxe at. If you want to be more precise, you could call it rock type, or an ore node type, or ice crystals type, whatever. But I think this will be specific enough for our purposes. So let's hit save here. Okay, now we have this type. We need to assign it into our resource node rocktall. So in resource node rocktall, let's add a export variable at export var node type, and we'll say resource node type as the resource that we're going to set here. So Control S to save that. Now we can click on our node, and we can assign the node type here. We could actually make this an array even if we wanted to, having multiple node types per nodes. So we'll just drag mineable.tres into here. So now we can just check if we're interacting with a node. If it's a mineable node, then we'll be able to mine it with a pickaxe. So let's hit Control S. And then let's go back to the harvesting tool. And here we actually are going to need an array. Because a harvesting tool like a pickaxe may be able to interact with multiple types of node types. So let's add a new export var, let's say affected nodes. And this will be, if I'm doing this right, an array of resource node type. Okay, and then save. Okay, now let's go back to the player scene, and we'll look at this. So we have the affected nodes here in the copper pickaxe.tres. So we can actually edit it here. So let's click here and add one node type, and that is going to be mineable.tres. Okay, cool. So that should be all we need there. Now back on the resource node, as I mentioned, we can make this an array as well. So just in case we ever need to have multiple types per node, let's do that as well. So an array, and then square brackets of resource node type. And then we'll change node type to node types. Then we can just take the array and expand its size to 1, drag in mineable.tres into here. And that's all we need to do to set our resource node as a mineable type, and then specify for our copper pickaxe in items that it can affect mineable resource node types. So what we'll do now is whenever we have a match, then we'll allow the pickaxe to interact with the mineable nodes like a rock. So in our harvesting tool.gd, we're going to check if the affected nodes, or affected types, I guess we should say. Yeah, let's call that affected types. Control S, and I guess we need to reset it here. So we'll just add everything back in to the array. We'll check that if whatever's in this array matches at least 1 in the resource node, then we'll actually interact with that node. In this case, that's going to mean we're going to run the harvest function on the resource node. Okay, so what we can do is loop through all the affected types and see if the resource node matches any of them. So for type and affected types, and let's make sure that has 1p there. We'll check, let's say body dot node types dot has. Okay, since that should be an array, and we'll check if that has the type. That's going to be an if statement. So if the body node types has the type, then we're going to basically allow it to interact with the body. So we'll print, let's say, match found at type, and let's do type dot resource name, and on the node on plus body dot name. All right. Okay, let me expand that so you can see the whole line here. So we check for all of the types. If the body has any of those types assigned, like mineable, then we'll match the type, and then we can do something with it, like do resource node.harvest. So we'll probably move the harvest function actually into the resource node instead of the equipable tool. So let's see if that will actually run first. Let's walk over to our resource nodes. Okay. And then we have match found at type. Okay, it didn't actually give us a name there on resource node rock tall, but we are getting those matches, so that's good. So why doesn't this work? Can we do just plus type then? Let's see if we can do string on the type. So just converting it into a string, will that work? And then let's walk around. Let's get that. Nope, that's just the resource ID. So what we might want is a display name on the resource node type. So let's give all of them a export var display name, which is a type string. Okay, well, now we can click on mineable.tres and just say mineable. Okay, and then in our harvesting tool, we just want to do type dot display name. Okay, now let's hit play. Now let's walk over here. And now we can see match found at type mineable on resource node rock tall. Okay, so that's good. We can basically harvest the nodes now. We just need to create the harvest function. So as I mentioned, I'm going to move the harvest function over to the resource nodes, since every resource node can be harvested. And I guess it makes more sense to do it at that level. So let's do resource node.gd, and I'll paste in the harvest function. We don't need to know the resource node. We're already on the resource node, but what we do need to know is amount, and this is going to be a integer. So we need to know how much we want to harvest from the node. Okay, and what we'll do is we'll take the current resources and subtract, so minus equals the amount. And then once we run out of resources, we do want to remove the node. So we can do that as a setter function. So let's do set value. So we're setting the new value. If value is less than or equal to 0. So if the value is less than or equal to 0, we're going to queue free on the node, which basically just means remove the node from the scene. So our harvest function, we remove the resources. If the resources drop below 0, it's going to remove it from the scene. And later we'll also add in like an animation here so that when it is removed, it'll be more obvious than just disappearing immediately. Okay, now back in harvesting tool.gd, we already know that it's matching, so we can remove this kind of debug. Unless you want it to be there, I think you could still do like print debug. And then let's come down here and do body.harvest. and we're going to do harvest on the amount. So we have the min damage and the max damage. We need to do a random integer value between those two. So let's do rand I dot range or underscore range. And the range is the min damage to the max damage. So let's give a comment here. If the body interacted is a resource node that matches one of the affected set for this tool, then the resource node will be harvested between the min and max amounts for this tool. And I'm actually going to take this bit here. Let's do a Control R and do a find and replace. So we're going to take min damage and we're going to replace that with, let's say, min amount, replace all. And let's also do max damage and replace with max amount, replace all. I think that's just a little bit clearer. We're not exactly damaging a node, though that makes some sense. We're just harvesting it. So I'm going to use min amount and max amount as the words here. So to finish that comment, between the min and the maximum. All right, cool. Okay, so let's test that out. In our player scene, we can see that the copper pickaxe has a min amount and a max amount of 1. So every time it hits a node, it's going to generate exactly 1 resource, which in this case just means removing it from the node so far. And then the rock resource has a starting resources of 1. So if it gets hit once, it should remove from the scene. Let's hit play and test that out. So let's go up to our nodes. I'll run into it. Oh, boom, it got harvested. And we can see the debug message there in the console. Let's harvest some more resources. Boom, harvested. Now, that didn't really do anything yet. It's just decreasing an integer value. But now that we know that we're interacting with it, we can actually generate the resources, pick them up, add them to the player's inventory, and then we'll kind of be on our way to getting this resource harvesting thing going. So let's create, let's say, another folder in objects, and we'll call it pickups. So this will be anything we can generate that can be picked up into the player's inventory, like a rock or a piece of wood. Let's do right-click on objects, new folder, and we're going to say pickups here. Enter for OK. Now let's right-click on the pickups folder and do new. I guess we need the GD script first. So this is actually going to be a node because the pickup is going to exist inside of the scene, which will add a resource to the player's inventory, but it does need to have a scene presence. So we'll add the script here and we'll say pickup.gd. And this will inherit from, I guess, static body 2D, since it will be a physics object in the scene. So let's create that. And we have this pickup.gd script. Okay, so in the pickup.gd script, let's give it the class name pickup. Okay, save that. So let's create a new scene now for our first pickup. Scene, new scene, other node, and let's look for pickup. Since we created the class name, we can just create it right here. Create our pickup, go to 2D view, and our pickup is going to need a sprite node. So let's right click, add child node, sprite 2D. And let's rename our first pickup to be pickup underscore rock. Let's hit Control S and we'll save it in our project. So let's save it into the resources pickups folder, pickup rock. Dot here, save it. And our static body is also going to need a collision shape. So let's right click here, add child node, collision shape 2D. And our shape is just going to be a circle shape. Okay, so we'll add that in. Now we need the sprite 2D. Let's go up to our art and let's get a object for the pickup resource. So I have it under the resources folder, rock item. Let's drag that into texture. And now let's make the collision shape actually match the shape here. So collision shape, click on shape 2D, shrink the circle to right around there. I guess here is nice. So a radius of 4. And now we'll have our pickup inside of the scene. Okay, so with our pickup, whenever we harvest the resource, we want to generate that many pickups so that our character can pick it up and add it to his inventory. So let's go to the resource node script, and we're going to add in which pickup we want to instantiate. So at export var pickup type, and this will be a packed scene. So we'll save that, click on resource node, and we need to assign our pickup type, which is, of course, pickup rock.tscn. So drag that in there. So now we have the pickup we're going to spawn when we harvest. So let's add in the spawning above when we actually decrease the amount. We'll create the pickup and then we'll decrease the amount. Okay, so let's run a for loop on spawning the pickup for the amount of times that we are actually generating resources. So we can do for in amount. So basically we'll just run code the amount of times. And then in is like which instance of running through this loop it is, starting at 0 and going up to amount -1. So we're going to want to spawn a resource every time we do that. So we need to have a spawn resource function. So we'll make that spawn resource. And that's going to mean we're going to create an instance of our pickup type. So var pickup instance equals, and then our pickup instance is going to be of a type pickup. And that's going to be equal to pickup type dot instantiate as pickup. And for right now, we'll just start with that. So we have harvest. We're going to spawn a resource. We spawn the resource. It should be in the scene. Oh, we do need to add it as a child to something though. So let's take a look at our 2D game level. We can see that our resource nodes are going to be under the game level. So we can get the parent and add the pickup to the parent game level. So let's get reference to the parent, but we only need to do that once. So we'll do something like @onReadyVar level parent equals get parent. Okay, it looks like that should work. So we'll take the level parent and we'll add a child, and the child is going to be the pickup instance. So whenever we spawn a pickup, we add it to the level as a child. So that would mean that in the hierarchy, if we look at game level, it'll be under here and show up somewhere down there. Okay, let's hit play and let's harvest the rock. So I'm going to come down here and boom. Okay, now we got the pickup to actually show up here. If we go up here, the next pickup shows up. We can actually check the remote view, look at the game level, and we can see our nodes are actually spawning down here. And then we can add another one. Okay, look at remote view, and yeah, we have 3 pickups showing up there. Now, those are all spawning at the 0, point, but where we want them to spawn is wherever the resource node is. So let's jump into the resource node script, spawn resource. We want to take the pickup instance dot position, and we want that to be equal to the position of our resource node. Okay, save, run again, and let's harvest those nodes. We come down here. Okay, we got the pickup to show up down there. Hit this, pickup shows there, pickup shows there. Now that's not very interesting if the pickups just show right on top of the node. So what I actually kind of want to happen is that these pickups are going to launch themselves away from the resource node. And once they've landed on the ground, then we'll say that they can be picked up. So in the pickup script, let's disable the collision shape until the pickup has actually landed on the ground. So in the pickup, let's do @onReadyVar collision shape, which is going to be a collision shape 2D, and that'll be equal to $collision shape 2D. When we start the script on ready, I want to take collision shape. And so what we're going to want to do is that whenever we create a pickup through the resource node script, we'll kind of want to launch it, disable its collision shape, move it a bit, and then once that's done, we will re-enable the collision shape so that the pickup can be picked up by the player. So inside of our pickup script, let's create that function so that we can move the pickup. We'll say function launch, which is going to take a, let's call it a velocity, which will be a vector2 having a direction and a magnitude, and then a time. Let's call it move duration. So that will be a float. So because this is a static body, we're going to have to set up our movement all through code. So let's go up here to the top and let's add in some variables. I'll say variable velocity, or we could say launch velocity here. And we'll default that to a vector2.0. So when we pass in the launch velocity, we'll set that. So launch velocity equals velocity. We'll also have move duration, which will be a float. We'll default that to 0. And then we'll say variable time since launch, which will also make a float and default to 0. And then we'll say variable launching is a Boolean, default that to false. So when we launch the pickup, we'll say time since launch equals 0 because we're restarting it. The launching is going to be equal to true. And the launch velocity set here. I guess we also need to set the move duration up there. I'll rename this to be duration, and then move duration equals duration. Just having different names so it's clear that this is the member variable up here, and then this is the parameter. Okay. Next, for function process, we're going to check if launching. So if the pickup is currently launching, then we're going to move it. So we'll say that the position is going to add in the launch velocity times the delta, which is the time between frames. And then we're going to add in time since launch plus equals the delta. And if time since launch is greater than or equal to the move duration, then we're going to stop the launching. So launching equals false. So that will handle the movement. What we also want to do is when the pickup is launching, we want to disable the collision shape. So let's actually add a setter there for the launching. So set is launching. So launching equals is launching. And then we'll say collision shape dot enabled is going to be equal to whatever the launching value is. So if we set launching and launching is true, then the collision shape is disabled. But if we set it to false, then the collision shape is going to be disabled. Now let's go back into resource node, and we need to calculate the speed and the direction that we want to spawn this pickup in. So that means at the harvesting node at the top, we're going to need to set a launch speed for the pickup. So let's export var launch speed, and that'll be a float. We can default this to something like 100 pixels per second, I guess. And we'll also have to do a launch time. So export var launch time, and we'll call this something like a float and 0.25 seconds. So that'll mean it'll travel for 1/4 of a second at 100 pixels per second. And then we'll generate the direction down here. In order to get the direction, we need to do var direction, which is going to be a vector2, and we're going to set that equal to a new vector. So we'll say vector2, then we need an x and a y value. So for the x value, we're going to randomly generate between two floats, and that's going to be negative 1.0 and 1.0 positive. Then we're going to do the same thing with the y value. Rand f underscore range, negative 1.0 to 1.0. So basically it's going to generate a random direction, and that can be anything from left, up, down, and right, and everything in between. So effectively it's going to create like a circle, and then our vector is going to point somewhere along that circle. So it could basically go 360 degrees. Now to make sure that when we get these values that it's just going to be a pure direction with a magnitude of 1, we want to normalize this vector with dot normalized after we create it. So that gives us our normalized direction, and we need to launch the pickup now. So pickup instance dot launch as the function, and we're going to pass in the velocity, which is direction times launch speed up here at the top, launch speed, and then we give it the time, which is the launch time or launch duration. Let's rename it launch duration. Okay, so that's our two parameters. And now the pickup instance can launch. Let's hit play and let's see how that works, if it works at all. So I'll come down here and we hit the rock or node. Boom. So we get a problem here, which is that the disable on the collision shape is not something we can actually set, supposedly. Let's see, collision shape. Then we have the disabled property. Okay, so we want disabled as the name of that property, not disable. Now we can save it, run it again. Let's go back to the OR. We hit it. Okay, and there we actually get it to spawn with our launch. It moves at a direction for a set time, and then it stops. And then supposedly it also re-enables it. So let's hit this one, and you can see the direction's randomized. So we can do that a few times. Let's also take the tall rock resource node, and let's change the starting resources, and let's make it 3, or you know what, let's even make it 5. So that means it's going to take 5 hits, generate 5 pickups before it goes away. So let's hit play. and let's harvest this node. So, okay, that one didn't quite work. Let's see, starting resources 5. Let's check the game level. If we click on these, okay, they all have the starting resources of 5. Let's look at the script, see what's going on here. So current resources is going to be equal to starting resources, which should be set to 5 here. Let's hit play one more time. I'm going to look at the remote scene. Let's click on the resource things here. And we can see the current resources is actually 0. So I guess current resources isn't being set on load. Interesting. Let's add a breakpoint here to this line, and we'll hit play and see what's actually going on. So we come in here. The current resources is going to be set to the starting resources. I see what's going on. So when we run the setter function here for current resources, we never actually set the field value. So current resources equals the value we pass in. Or instead of just calling it value, we could say resource count. Okay, so I'll copy that, paste that there, and paste that there as well. Now we can hit save. We won't need this breakpoint anymore. Hit play, and now that should be working. Let's go down here. We hit the rock. Okay, we got 1. Let's hit it again. 2, 3, 4, 5. Okay, so you see we harvested 5 nodes here. Now these pickups actually are static bodies. I really should have made them area 2Ds because you can see that as a static body, they interact with physics. We don't want them to interact with physics. We just want to be able to pick them up. So we'll have to change that. But yeah, all of our resource nodes, we can harvest them 5 times here. And this one, 5 times as well. Okay, so that is pretty much working. Now we have 15 pickups and we need to be able to add them to the inventory. Let's exit out of the game. Let's go into the 2D scene for the pickup rock. Okay, in the script here for pickup, we're going to want to retype this to area 2D. And we're going to retype the pickup rock in the scene to area 2D as well. So change type with right click, change type, area 2D. Now a area 2D, we can look for an interaction, but it's not going to affect the physics. But we still should be able to move it with script like this. Let's test that by hitting play. I'll run in here. So we get our pickups and they are in the scene, but we can walk over them, which is what we would expect actually. Okay, so let's hit close. Now I did notice that the pickups, they still have the sorting going on. So inside of the ordering, for now, I'm going to just change this to be something like -5. So if something like the player has a value of 0, it's just going to hide behind it at all times. So let's hit play and let's test that out here again. So this will just basically force the pickups to hide behind the player by default. So for our pickup, we can have it monitor to see when a body enters it. And if that body has a inventory, then we'll just add the pickup to the inventory and we will remove the pickup from the scene. So first off, let's go to player. Let's call it a node here for the inventory. I will right click, add a child node, and let's make it a new node. I'll rename this to be inventory. And now let's create a script for inventories. So for the inventory, let's add a new script here. We can leave it in characters/inventory.gd, I suppose. Create, and let's give it a class name inventory. In the inventory, let's create a dictionary for resources. So it will include which type of resources are in the player's inventory and how many of those resources are in the inventory for each type. So in our inventory, we can create a dictionary for resources that we want to track. Something like @export var resources, and this will be a dictionary, and we set it to equals. This thing equals curly braces means dictionary here. So our dictionary will contain keys, which will be the resource that is in the resources dictionary, and then the values, which will be how many are in there. So let's go back to pickup rock, and we can see that in the nodes, we can do body entered, body node 2D. So basically in our script, we want to connect to the area 2D itself. Instead of connecting it right here, just to make sure it always works for any pickups we create, let's actually just set that up in code. So if we have, let's say, a function ready, so function underscore ready here, and then we're going to connect to itself. So let's do body entered, and the callable is going to be on body entered Yep, let's just do that. And then down here at the bottom, we'll make that function underscore on body entered. Then we have the body node, which is a node 2D. Let's pass. And then I want to add the underscore back up here at the top. Okay. So basically when the script starts, we're connecting to its own signal. And then we can come down here. We'll check that if the body that entered the pickup has a inventory, then we're going to add the pickup to the inventory, and we're going to remove the pickup from the scene. So let's do var inventory equals body dot find child. In the find child, the pattern we're looking for is that it is from the inventory class. So you can use a string for, I think, the node name, but this will also work with class types. So let's check inventory.gd. So class name inventory should match here. So basically a node that has a inventory script attached should be found by this body.findChild inventory. So if the inventory is valid, we're going to do inventory.add resources. So let's say resource type, and we'll write that up at the top, and then the amount, which is going to be 1. So up at the top, let's add in @export var resource type, and that will just be a type of resource. We can come up here and be more specific later on, maybe make it like build materials instead of just resources, but it should work fine for now. So now our inventory needs to add resources function. So in inventory, let's create function add resources. So we need a type, which is going to be a resource, and we need a amount, which is going to be an integer. So when we add resources, we're going to find the key in the dictionary if it exists, and if not, we're going to add the key to the dictionary, and then we're going to set the amount of the resource inside of it. So we're going to do resources of type, and we're going to set that equal to whatever the current value is. So resources.type, and we're going to add the amount. Okay, now back in pickup, once we add the resources, we can queue free on the pickup. So after adding the pickup to the inventory, we need to queue it free from the scene. So let's remove it with queue free. Let's go ahead and test now and see if all of that actually works. So let's hit play. I'm going to look at the remote scene. Let's expand the game level, the player, and look at the inventory here. So in the inspector over on the right, we can see the resources, the dictionary here. Now let's look at our game view. So I'm going to harvest this resource. Let's go pick it up. Okay, so it almost worked. We got to the add resources. So invalid get index, null. The type is null. Right, so we need to actually pass in a resource type to that. So that would be coming from pickups here. So the resource type is something we actually didn't set on the resource. So that makes a lot of sense. Let's click on resource, and we'll need to set a resource type here. So for the resource type, let's go into the items folder, and I'll right click and create a new resources folder inside of here. So these are item resources because they exist inside of the inventory. Let's right click here, create a new script, and this is going to inherit from resources. And we can call the resource script something like resource item, and it inherits from resource, not from resources. So resource item, or item resource, whatever makes more sense to you. Let's create that. Okay, so now we have this inside of the folder. Let's give it some fields such as @export var display name, which is going to be a string. We can give it a texture as a texture 2D as well, so that if we need to display it in an inventory or something, we know what to show for it. And aside from that, we'll just hit Control S and save it. Oh wait, we do need to give it a class name. So class name is going to be resource item. Yep, okay, that makes sense to me. Now let's create a actual resource from that script. So let's right click in resources, item resources that is, go to new resource, look for item resource or resource item, double click on it to create it, and then we're going to call this a rock item or resource rock. Yeah, I guess that makes sense. Okay, let's save that there. And now we can double click on it. We can give it the display name rock. We'll give it the same resources texture that we used to show it in the game. So rock item. So if it exists in the inventory, it'll actually show up with the same image. And now let's assign resource rock.tres to pickup rock. So if we drag this into here, now we have the item resource type associated with the pickup, which is the object that exists in the game. So we pick up a copy of the actual resource, not the pickup rock node itself. So let's save that. And yep. Okay, let's test things out again. Let's hit play. Let's go pick up a resource. Let's walk into it. Okay, so we have the resource now. Invalid get index on dictionary. So I'm guessing it's this part right here, trying to look up a value that doesn't exist. So let's add a if statement up here. So do if resources dot has, and we'll look for a type. And I think that's looking for the key. Then we'll do this as before. Okay, so let's save that. Else, what we'll do is we'll say resources at type is going to be equal to the amount, because we're assuming that it hasn't been set yet, so the amount is 0. Let's give that a shot. I'll add a breakpoint for both of these, and we'll see what happens. I'll hit play. Let's go down here. Let's get the resource. Okay, so of course it didn't have the type, so we're going to try to add it now. Get rid of the breakpoint. Let's hit continue. Okay, execution resumed. So let's take a look at our remote scene, the game level player inventory. So we can see in the dictionary that we have a size of 1 now. And so when we added it, I believe this should be the resource here, and then this should be the count. So let's continue. Let's get another pickup so we get it, and let's continue. Control's got a little screw there, but let's go click on the inventory and let's see if it was able to add another copy of it to the inventory. So we expand the dictionary and now we have 2 of the item. So the only thing is that the item's kind of showing up a little weird here. Let's close the game there for a second. For the type, I'm going to actually rename this to be resource item. And let's add resources. Yeah, add resources. Yeah, okay, sure, that's fine still. I wonder if this changes anything. So let's go gather a couple resources and see how that shows now. Okay, so we got our resources, remote, game level, player, inventory. Let's look at the dictionary, and it's still showing up. Okay, so now if we go ahead and we collect some of these pickup items, like so, let's go check the inventory by going to the Godot engine, remote view, game level, player, and we look at inventory. And we'll see that we're picking up the resources now because our dictionary has items. You can see that the resource is being stored here as a object. It's a little hard to tell exactly what this is looking at the inspector view, but we can see that we picked up 2 of that item. So seeing the objects here is a lot easier when you would be looking at, let's say, the debugger view. So if we, let's say, look at the inventory script, and we have the bit here where we're adding something to the inventory. Let's add the debugger point at that point, and let's go collect another resource. Okay, so now it's going to stop at that breakpoint, and we can see the object here represented outside of the dictionary. So you can just click on the object, and you can see what type it is here. Rock with a texture. So out of the box, looking at the dictionary might not be the most convenient way of seeing how many objects you have of which type. So what we could actually do is create a in-game UI so that we could see how many of each resource we have picked up. So let's go ahead and exit out of the game now, and we will do that. So let's go up to scene, new scene, and do a user interface. So we have the control node here. I'm going to change the type of it to something a little bit more useful. Let's right click and change type. So let's expand the control nodes, go into container and find a container that would be useful for showing a whole bunch of icons with how much we have in the inventory. So I think we'd be looking for something like a grid container. We can try that. So let's change it to a grid container. For columns, we can just decide how many items we want to go across before we jump down to a new row. So I'll say something like 5 for now is fine. We can rename this to be resource display. Okay, and now let's Control S, save this in our project. So I'll create a folder for UI, and we can just call it resource display.tscn. So in our resource display, we're going to want a little side-by-side with a label showing a number, and then something like a sprite showing the texture of the resource so that we know how much of that resource we have. We could also add in the name of the resource, optional if we want that. So I'm going to right click here and do add child node, and let's go into control. So we'll need another subcontainer for that. Let's go to container, and then we can do box container and horizontal box container. So this will make each item go horizontal, I believe. Let's try that. And then under this, we'll right click add a child node. So let's get a label for the number, and I'll right click on hbox container again. And let's see what we can use for showing an image. So under control, we have texture rect. I believe that's what we want. So let's create that. I'm going to reparent the texture rect to be above the label, so the image comes first. And then let's create a little sample here so that we can see how it will look in the actual thing. So let's go to Art, Gatherers Exterior, Resources, and let's grab something like Coin Copper here. I'll drag that in. Okay, so we can see that this is stretching the icon in a way we don't want. Let's go to Stretch Mode, Scale, and do Keep Aspect. Okay, that looks a little better. And now let's go to the label and put 0 for the number. Let's rename the HBox container to be, let's say, resource item display, I guess. Okay, and if we duplicate this a few times, then you'll see roughly how the UI would start to look. If we zoom out all the way, then we'd have this little UI in the top left-hand corner, and it would be going to the right. Now, of course, we can see that our icons are too small. I'm going to delete resource item display 2 and 3. Don't need those right now. So next, let's go to the texture rect, and let's fix the sizing of our little icon here. I'm going to go to expand mode, and let's try fit height proportional, or no, fit height. And then let's do fit width. We could try fit width proportional. Okay, that looks good. And then we have the number over here. So we'll need to kind of make this bigger than it is right now. Okay, so we can check how big it's going to look in game now by running the current scene. Remember that in our window settings, the scale is increased by 4 times or so. So that's why it appears so big here compared to here. Now, we probably don't want these grid items to show at the very top left corner. So maybe we can add a margin around our grid box. Let's go to the resource display. I'll right click, add a child node. Let's look for margin container. Okay, and then drag resource item display under the margin container. And in our margin container, let's go to, let's see, theme overrides constants, and let's set some margins here for all 4 directions. And let's try 10, 10, 10, 10. So with that, now our actual grid items are inside of this larger container. If we run the scene, it's going to, I mean, it's kind of big, but that'll be a lot better, at least. So now we're going to need a couple scripts, one for the resource item display so that when we set a resource and a value here, that those will be updated to the texture and the number here. And then one for the resource display where we'll have it listen to the player's inventory, and whenever the values change in the inventory about how many resources the character has, then we're going to update the display. So let's right click on resource item display and do a new script so we can attach a script. And we'll save this under UI/resource item display.gd. Okay, let's save that there. So I'll get rid of this stuff down here. And what we're actually going to want here is going to be a class name. So we'll call it resource item display. Then down here we'll have our resource type, which we'll have to get the item type. So let's see, items, resources, we were calling it resource item. So if we do, resource item here, then that'll be good. By default, it's nothing. We'll also need a couple onReady vars. So onReady var of type texture rect equals $texture rect. And then we'll need the label on ready var label type label equals $label. We could also create a simple function down here, function update count. And this will take a count as an integer. And then we take the label.text and we set that equal to the count. We might need to make that a string. So let's do str of count. Not sure if that's actually required or not, but just in case. All right, so that'll update the label there. And now we need to create a script for the resource display. So let's attach a script to resource display. So the first thing we can have here is going to be a list of resource item displays. So that will be a array. So var resource item displays, or we could just call it displays actually, and that'll be of type resource item display equals an array of resource item display. So what we'll do with this is that whenever the player inventory adds a new type of resource, we'll create a new resource item display. So for that, we need the template, which is what we created already, and then we'll create a new copy of that under the margin container. So let's add an export var for item display template, which is going to be of type No, not resource item display, actually. It's a packed scene because it's from the project. Now we can click on resource item display and we can set the item display template. So we have to save our resource item display to the project. So I'll right click here, save branch as scene under UI, and we'll just save this here. Okay, now we can remove the resource item display from our scene because we don't want it to be there by default. And instead on resource display, let's go to the UI folder and let's grab the resource item display and just drag that in there. So we have the template and we'll create an instance under the margin container whenever we have a new type of resource. We don't need ready and process functions, so let's get rid of that. We are going to need the margin container. So at onReadyVar, and maybe I'll call it something like display container inside of here, which is going to be of a type margin container. And we're going to look for $, we'll rename it to be display container. So let's make sure that's the name of our margin container. So I'll rename it in the scene view to display container. So we want to connect our resource display to the player's inventory. So we can look through the game level scene if we wanted to, look through all the nodes and find a inventory node, which would mean a lot of redundant looking at other nodes in the scene that don't really have anything to do with our player. Or what we can do is give the player nodes a group, which is like a tag, and then we can search the nodes that have that tag player and only look at those nodes instead of looking at every node that's active in the scene. So to do that, we would go to the player node in the player scene in our project, go over to the node tab, and instead of signals, choose groups and give it the group player. So now we can search this node just by looking for the tag player. Let's go to resource display inside of here. And we'll have a function underscore ready. And first, let's find the player. So the player is going to be of type player controller, but we haven't actually given the player script that class name. So let's give it class name. And we could just call it player, actually. That's more consistent with the name of the script. So class name player. Now let's go over to resource display. So we're looking for a node that is of type player. And to find that, let's get the currently active tree. So that would be like the level or the main scene for the game. And we're going to look for a group. So if we look at groups, we can do get nodes in group, or we could get first node in group. So I'm writing this to be a single player game, and we would only expect it to be one player. So for that case, we'll just get the first node in the group. The group name is player. So we're going to get that player node there. So then we need to get access to the inventory, and we'll actually make that a member variable. So up here, var player inventory, which is going to be of type inventory. To find that player inventory, we need to search the player node. So player inventory is going to be equal to player.findChild. And the pattern we're looking for is inventory as a class name. And that should be as a inventory. This part's probably unnecessary, but it doesn't hurt. We're being very specific. We're looking for that inventory script and we're setting it up there. Okay, then what we need to do is connect to the player inventory signal. But currently there's no signal for inventory. So let's go to the inventory script and create one. So in the inventory script, let's write a signal. So to do that, we can do if our signal resource count changed, and that is going to mean that we need the type and the new amount. So type resource item, and then the amount is new count, which is going to be of type integer. So after we add resources, we want to emit that signal. So we can come down here below the if else and write emit signal. So the signal we are emitting is of course resource count changed. And then we pass in the parameters. So the type is type and the count is the new amount. So that would be resources type, which is going to give the value associated with the key there. Now that we have the signal emitting, go back to resource display and we can connect to that signal. So player inventory.connect. So we're connecting to whatever that signal was just called. Resource count changed. So just paste that in there. And then we need to give the callback method. So we're going to have a function in here called on player inventory resource count changed. Okay. And now we just have to write that function. So add a couple new lines and then function, let's just copy and paste this name. It's kind of long. So on player inventory resource count changed, and that's going to take the same parameters. So we have the type of resource item, and then we have the new count, which is an integer. And I guess this is going to be turned void, so we can specify that as well. Okay, next, let's make sure there's no errors. Okay, great. So let's change this pass and write a print. So new count for, and let's do type dot display name is going to be is, and then, well, we need to convert this integer into a string. So string new count. So as long as this resource display is active in the scene, we should be able to get this callback to run. So let's go to the game level, and we can add it in here. Maybe later we would have like a main scene load the level, and it would only have the resource display load once, not every time we load the level. But for right now, let's just, for the sake of simplicity, we'll add the resource display straight to the game level. So let's right click in here and add a child node. So we want a canvas layer. Usually you want this as the base for when you're adding UI controls to the scene. It'll keep the UI positioned in its place no matter where the camera is moving around in the scene. So if your UI is in the top left, it'll always stay in the top left no matter where the player and the camera goes. So canvas layer, and then let's add in our resource display. Just drag and drop an instance of the scene and then position it under canvas layer. Yep. And okay, and now that we have that active in the project, let's hit play. And let's see if we can get that callback to occur. Okay, so first off, in the scene displays resource item display is an array of resource item display. So what's going on here is that this should be the type, not assigned. So we're going to put array resource item display over there and get rid of the equal sign. So by default, that's just going to be a empty array. Yep. Okay, now let's hit play and run that again. Okay, so scene runs. Let's see if we get the callback print messages when we pick up an item. So I'm going to come here. Okay, we have new count for rock is 1. So our UI is now responding to when we pick up items. So it knows what type and how many. So that's very good. That's what we need to start adding to the resource display UI. So we already have the display item template. First, we want to check in our array if a template that supports the specific type already exists, and then add the new count into that. And if there isn't one for that type coming in, then we create a new instance of the resource item display and reset the type to the new type. So first, we'll find existing item display for type. If none exist, create a new one. Okay, so to find it, we have to do a var. So var current display, which is a type resource item display. So then we need to loop through the array. So for display in displays, if the display dot, let's see, resource type, I think that's what we want. Did I really make that a capital though? So let's go back and check that script. Resource item display. Let's open the scene. Let's look at the script. Yeah, I did actually. So let's make that resource underscore type be more specific. You know, just standard naming conventions. And let's go back here and do display dot resource type is equal to type. So if that's the case, then we've already found the current display. So current display equals this display, and we can break. So once we find the correct display, we no longer need to continue through the for loop. So then we're going to check if the current display was never found. So if current display is null, then we're going to create a new display. So we want to instantiate under the display container a new instance of this item display. So we're going to take, let's see, item display template. So var new display equals item display template dot instantiate. Okay, and then we need to set the parent to the display container. So display container dot add child new display. Okay, and yeah, I think the display container will take care of positioning it. So we just need to set the new values into that. Okay, so the new values is going to be, we set the resource type. So let's actually specify this as a resource item display so that we can see what member variables it has. And then we're going to instantiate as a resource item display. Okay, and now we can do new display dot resource type equals type. And then we'll say new display dot think I had a function update count. Yep, update count. And we're going to pass in the new count. Okay, great. So we just need to do the same thing up here if we have a current display. So we'll do current display.update count new count. So here we create a new display and we set the resource type and update the count. And then here we find the display based on the resource type, and then we just update the count. Okay, so here we can say find existing display and update the count if one is found. Okay, so hopefully that's not too complicated there. Let's hit play and test it out. So we're going to go gather a resource and then boom. And then, okay, we have our display added to the top left-hand corner. The only thing that's a little weird here is that the margin did not seem to work. And I think I may have seen why that could be. So if we look at the game level and we look at our resource display, we'll see that the margin is actually going outside the bounds of our screen by the looks of it. So let's jump into here, take a look at the resource display. We got theme overrides. We got the display container. Could it be that this should be negative? No, that's not right. Okay, I guess we can hit play and we'll take a look at the remote views up here in the game level. So we take a look at the resource display, but we got to look at remote. So let's see, canvas layer, remote display, display container, and we have our resource item displays under here. Okay, that's kind of interesting though. We have two set here. All right, so that's definitely a bug. We get a new one added every single time. Yeah, okay, I think I forgot to add it to the array. So let's do that part first. So when we create a new display, we need to add it to the existing displays array. So displays dot append, and we're going to append the new display. Okay, that way, when we search through the array, the new display will show up. So it should only create it once. Let's hit play. Let's gather our stuff. Yeah, now that's working. Okay, so to fix the positioning on the resource display, let's go to resource display here and try making the anchors preset full rect. Okay, so that should make it the full UI view of whatever we attach it to. So if we go to game layer, okay, that's actually kind of like what we just had. Let's see, let's check the layout. Transform. Oh, position -10, -10. Okay, that might be our problem here. So I'm going to reset that. Okay, now the position is correctly in the top left. So let's hit play and we'll see if it actually positions things correctly. Okay, good. It is. That's nice. So now to demo that this will work with other types of resources, let's just create a wood resource and put one randomly on the map for us to pick up. Okay, so under items resources, let's create a new resource. So we're looking for item resource item. This will be resource wood.tres. So we just need a name and a texture. So this is going to be, and then the texture, let's go up to resources and we'll do wood brown. So maybe we rename this to be brown wood. You could call it whatever you want, really. Okay, and now we need a pickup object associated with that. So I'm going to duplicate this pickup rock as pickup brown wood. Let's double click into here. Let's change the resource type here to resource wood. And by the way, if you don't like how it shows the file name, like here in resource rock, you can set a name here, rock. You could go into resource wood and you could set brown wood here as well. So then when we look at our scene and it references it in the inspector, you'll see it referenced by name here instead. So you can hover over it and see it's resource wood.tres. Let's rename the pickup to be pickup wood. And then we need to change the texture to be our wood textures. Just put that there. And let's change the size of our collision to actually match our wood. So something like that is pretty good. Now let's put a couple inside of the scene. So first I'm gonna first let's close a few of these tabs. Okay, and now let's go to the game level and let's drop some of these pickups in. So pick up brown wood, pick up brown wood, pick up brown wood. So now we have some extra pickups in the scene. Let's hit play. Now notice, because we didn't run the launch method on these pickups, that they just exist in the scene. They're not moving or anything. So let's go get this one. Okay, and I guess I didn't set a texture there. So I guess we still haven't set the texture here, but we should be able to get 2 to appear. So let's get 2. And we did get a second to appear in our grid, but it's not showing quite properly. But you can see how the first one had a 1 and now a 2, and the second one had 5. So at least it knows that the types are separate. Let's work on setting the texture. So in resource item display, let's jump into the script. We can just have a setter that whenever we set this resource type, we're also going to change the texture rect texture. So let's make a setter function here. So set new type, and that's going to mean resource type is equal to the new type, of course. But we also want to update the texture rect dot texture is going to be equal to resource type dot texture. Okay, now if we hit play, it should correctly display which item is which up here. Okay, and now we'll get the rock, and well, the rock's pretty big over there, but yeah, it's definitely showing the right texture at least. Now we just need to get the grid layout to work. So let's take a look at our resource display scene in 2D view, kind of zoom in here, and let's try dropping 2 items under display container. So resource item display and resource item display. Okay, so we can see they stack on top of each other here. Really, I guess what we need to do is that the resource display should be under the margin container. So let's make it so that the display container is actually the root scene. So right click, make scene root, and let's bring these 2 under the resources display. Okay, so that lays things out correctly. Now we can rename this to be grid, and we'll rename this to be resources display, or resource display actually. And then we're going to attach our resource display script to this node. We're going to remove it from the grid node. So let's remove it there. And then we just need to make it in the script so that we're taking this grid instead of the display container as a margin container, and we're going to add it to the grid. So grid is going to be a grid container. We're looking for $grid. Oh, we could just make it grid container actually. And we'll rename it grid container as well in the scene view. Okay, so now a grid container, we just need to add the child to that instead. Okay, now let's go to play. Let's collect our resources. Oh, yeah, of course. So we have to change what this extends, which is margin container. Okay, now let's hit play. Let's go collect our resources. Instantiate on null value. Oh, right. Because we changed where the script is, we need to set this up again. So take the scene, resource item display, and put that in the slot here. In 2D view, also remove the test resource item displays. Okay, now finally we can go to play mode, and we can pick up our items. So there's our first, and there's our second. Okay, cool. So we're collecting different types of resources here. They're kind of big on the screen, but you can see how we can easily keep track of what resources we have. Now in your actual game, maybe you'd put this in an inventory or something so you couldn't always see it, or we just shrink it down to the top left of the corner. I don't know if you want this to be more like an RTS or more like an RPG. But let's actually try to make that a lot smaller. Okay, so first off, the resource display, let's take the margin and make that 5. Since it's being amplified by 4 scale, it's really like 20 pixels when it's 5. And then let's make it so that each item is smaller. I'll add a couple test items back in here so that we can see what their size is. And then we're going to work on resizing those to be smaller. But let's start with the resource display size, and I'll make that, let's say, 26. So I want to take our resource item displays for the texture rect. I'm going to shrink that back down to keep size. So we'll just show the actual size of the sprite. And then we're going to need these labels to be much smaller as well. So on font size for theme overrides, I might take that, override it to something like 8. Okay, so I'm not really sure why the text down here kind of floats into the middle with this HBox container. I'm actually going to try changing the resource item display to a different type. Let's try changing it to a flow container. Let's see, a horizontal flow container. Yeah, let's try that. Okay, so that makes the text come up here. And I kind of want to shrink that if I can. So let's resize this. Yep. We can try something like that. Now let's go into the script and just make sure that we are using this type, which I think was horizontal flow container. So just change the script resource type. So next we'd like our texture to be centered with the text as well. Centered vertically, that is. So let's see if we can get that in layout. So if we do stretch mode, maybe we can do keep aspect centered. Okay, that actually seems like it's good. Keep centered or keep aspect centered. Let's try that. Keep aspect centered. Let's hit play. Okay, we see our items up there. We got our new resource we added in, and we can collect those resources. So that's looking pretty good. Not perfect, but it definitely works for right now. Okay, now we can go to resource display. Let's get rid of these default dummies and save the scene. Okay, so now let's go hit play one more time, collect the resources, and we can see that now that we have this display in the top left-hand corner, it's pretty obvious how much of each resource we have as we pick them up. So it would be a pretty useful indicator. You could also move this same thing into a pop-up window, like an inventory, when you press a key like I or something, if you'd rather it show up there rather than on the screen at all times. But that's pretty good for showing our collected resources. So next, I think it would be a good idea if we created an actual game level for the character to run around in. So to do that, we'll need a tile set, and we'll need to set up some physics collisions to those tiles. So in the game level scene, let's right click on game level, add a child node. I'm going to look for a tile map. So add that. And then the tile map is going to need tiles. So to get tiles, let's go to the art pack, go down to tile sets, and then we can use some of the tiles here. So let's start with tile set grass. I'll just drag that in here. So our tile map is going to need a tile set in order to have tiles to draw onto the tile map. So let's create a tile set in the top right in the inspector with tile map selected. So go to tile set empty, do drop down new tile set. And then for this, we're going to left click and do it. Now we have this window for tiles. So if you go into Art Gatherer's exterior tile sets, we can come down here and bring in some tiles. So I'll start with tile set grass, drag and drop that here. And we can automatically create tiles in the atlas from this tile set image. So we'll hit yes, and you can see that it separates all of the tiles to 16 by 16 tiles, which is what we expect for this. So to draw with these tiles, we want to click on Tile Map at the bottom, click on the tile you want, use the paint tool, and then start drawing onto the tile map. So you can just kind of draw, and the tiles will go into their space. You can see in the tile map on the far right, the tile size here is set up 16 by 16. So you want to have this set to whatever size tiles you're drawing so that they line up in the level correctly. Now, right now, these tiles don't have any collision added to them. Let's start by using this rectangle fill tool, and I'm going to fill in this green tile, something like this. And then let's draw the edge tiles as well. So I'll use this one in line mode to go from here all the way up to here. The other side on the right up to here. This one at the bottom from here to here. And then these edge tiles, something like that. And then at the top, we'll have this corner. We'll use this one to go the middle section and then the top right hand corner. Okay, so then we kind of have our little island tiles set up. Now to add physics collisions to this tile map, in the tile map inspector, you go to physics layers, add a new physics layer. And in this physics layer, we can see the collision layer, which is where the collisions are going to exist when we set them up inside of this tile set editor. So basically anything checking for collisions on layer 1 can be blocked by these tiles. So go to tile set now, and we want to paint a property of the physics layer 0. So when we add in the collisions, we're adding it by adding a collision shape on physics layer 0. So let's start with these bottom tiles here. I'll left click on them. So by default, it's going to just create a box around the full shape size. But you can click on the corners and pull them up like this if you don't want the collision shape to actually be the full tile size, which in this case makes sense because these tiles are only half tiles, and then you have theoretically the water beneath it. So I'll make it something like this right here. And then to take this same collision shape and copy it over to these tiles, just left click on them and then left click here. And then we'll just keep taking the template you just created and applying it elsewhere. So now if I was to hit Control S and hit play, we can walk down here to the ground here, and these tiles are actually going to block our character's movement. Now everything else does not, as you can see. And also our tile map needs to be definitely behind the player in terms of sorting. So to make sure it sorts on bottom, you can click on tile map, go to ordering, and make the z-index something like -50. Okay, now everything else in the scene shows on top of the tile map, so that's more correct. So now for the rest of these edges, you could either create a razor thin physics collision where we have these black edges, or you could consider just adding water tiles, and then the water tiles have a physics collision. But then if that would be the case, Or you could consider adding water tiles, which would be unwalkable. But that could cause a problem too, because if you have something like a bridge or boat, then those could be affected by the physics collision as well. So the next thing we're going to want to do here is to add in probably the water tile set. So really in this pack, that's just one single tile. So let's go into tile sets and look for tile set water, and then we can drag and drop it into this tiles area. Or actually, you do that on the tile set tab. So drag it into tiles, but in tile set. Automatically create the tiles. Then let's select this tile, and we will give it the collision shape. So you can hit F to do the default collision shape, and then left click on the tile to make sure that it gets added in. So with our tile map, we'll also create a separate layer for the water tiles to sit on. One reason for doing that is that ground tiles, like this one, might not have the entire tile filled in. So you would want to have some water under it in the background. And that would be possible if you use multiple layers. So let's call the first layer, layer ground. That's what we already drew on. And then add an element, and we'll call this one water. So to draw on the water layer, click on this drop-down menu, go to water. And now you'll see that all of the ground tiles kind of fade into the background, meaning that those exist on a different layer than the one we're working on right now. Now, I also want to take any water tiles and have them behind our ground, since those would sit like, since those are sitting under it. So for the Z index on the water layer, I'm going to set that to -50 so that it's automatically below everything else here. So then I'm going to select the water tile. So in this case, I don't want to put water under anywhere where there is ground, because that will end up causing collisions. Even though the ground tile doesn't have collision, the water tile does. So in this setup, I'm just going to be careful to go around the land and not draw inside of it. So let's click here for a rect shape, and then let's drag in some water tiles. So just draw in the shape. Then we can also go up here, draw in the shape, and really you can make it as big as you need to. So if you want to have a large tile map, just feel free to drag in a whole bunch of tiles. Okay, let's also create another area over here for another island that our character will eventually be able to walk over to. So I'm going to delete and cut out some water tiles, just whatever I want the shape of the island to be. Can make it something like that, sure. And now let's switch over to the ground tile and click on tile set grass. So we'll start by filling in this whole area with the grass tile. So use the rect tool and make sure you turn off the eraser. So let's drag in the grass over here, 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 and here. Now we just need to fill in the correct tiles that surround that. So down here should be this one. Then we can drag like this, put that there, and here, 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 just kind of filling in the edge tiles. So let's do that. Okay, now we need the left side. So we'll fill in this. And if you wanted to, it's possible in Godot to create auto tile rules. I don't think I'm going to be covering that in this video, just for simplicity's sake. So we're just kind of going around the border and doing this manually for right now. So lastly, we do need to add water tiles here. And I guess that's already there. But let's go to water and then draw in water tiles at this bottom line. And that should pretty much be good for right now. So let's go ahead and hit play and make sure that it is working with the collisions. So we come over here and the water blocks us, as well as the bottom of this ground down here. So next we need to figure out how we're going to build a bridge between these two areas. So let's open up the tile set again. And I'm going to drag in this tile set floating bridge to this area, and we'll automatically create tiles for that. Now these tiles are going to go on a top layer. So I'm going to once again go to the tile map, add an element, and we'll call this top layer. Let's leave the Z index at 0, and I'll take the ground and make it -5 for right now. Okay, and then let's use the tiles here to put a bridge across the water. So let's switch to the top layer, use the pencil tool or the paint tool, click on the tile we want, put it down, and then add in the bridge area and the final piece over there. Now, right now, even though visually it looks like we'd be able to just walk across this bridge, the reality is that the water under it is causing a collision to occur. So we wouldn't actually be able to walk across it. Now, there's probably a good handful of solutions to this, but in this case, I'm going to do the simplest one possible, which is just going to be that we'll have a separate water layer where whenever we put a bridge in our game, we'll just make the water under it not have a collision shape, since we don't need the water for anything else really other than visuals and causing collisions. So to do that, we're going to go to water. I'm going to right click on the base tile and create an alternative tile. On this alternative tile, we're going to have no collision shape. So we just use this alternative tile in Tilemap paint mode, and then we're going to add these no collision tiles on the water layer. So just like this, making sure that all of those tiles have no collision. So now we should be able to hit play and actually walk across the bridge. So let's go over here and we can walk this way. You can see that now the water is allowing us to cross. Really, the bridge itself doesn't do anything other than a visual. It's just the lack of a collision shape that's allowing us to cross the bridge. Okay, so now we can hit play and test this out. So we'll walk over here. The water in all other places still blocks us. But if we go to this area with the alternative water tiles and the bridge, we can walk right across it. So now we can access the second island, which is pretty cool. Next, let's create a second harvestable node, which will be a tree. And we'll make it so that you can only harvest it if the player is equipping an axe instead of a pickaxe. So let's go into our objects folder where we have the resource nodes. And I'm going to start by duplicating the resource node rock tall. And let's call this resource node tree. So we'll double click into it. And of course, the first thing we're going to want to do is change the sprite. So in the art pack, we'll go to the objects and we'll find where we have a tree we can use. So I guess we'll use this pine tree. Let's drag that in there. And we can also rename the scene file to be pine tree as well. Or let's do tree_pine to have it sort better alphabetically. Let's rename the node in the scene, resource node, pine tree. And the pickup type, well, we already created that. It's going to be brown wood. So drag pickup brown wood into the pickup type scene. We'll leave most of the other settings alone here. The last thing we need is to change the node type. So this is going to be for nodes that are harvestable by axe. So we need to create that type in resources types. So let's create a new node type. I'll right click, new resource. Let's search for type. And then we have resource node type.gd. Let's create that. And we can call the resource type basically whatever we want. Since the first one was called mineable, I'll just call this one axeable. I don't know if that's even really a word. But it just refers to something that can be harvested with an axe. So let's save that type and click on the resource node, and then let's drag in axeable to replace mineable.tres. So now we know that this is a resource that will be harvested by a axe. So next we need to set up the tool, and I think we have that in items folder. So we have the copper pickaxe.tres. Let's duplicate that with Control D, and I'll do copper axe.tres. So double click on copper axe.tres, and we'll have the affected types here. So we need to switch to the other affected type of axeable. So next we need to switch the affected types here to axeable, as we were just talking about. So let's load, and we'll go into objects, resources, types, and then axeable. Okay. And we need to change the name here from copper pickaxe to copper axe, and the texture. Of course, we'll use the axe icon for that. So in tools, we have axe copper. Let's drag that in there. And now we have our second type of node and the way to harvest it. Let's add some trees to the game level. Obviously, the file system has a lot of items now. So we could just filter by typing in resource_node if you want to quickly find the tree. So I'm going to drag this into the scene like so. We can put a few of these trees in, which will be harvestable with an axe. So just wherever you think is good for them. One thing I do want to change, though, is the position of this collision shape. I'll move it down a little bit inside of the resource node pine tree scene. So open that up, collision shape. Let's just W to move it and move it down to the base of the tree. I might shrink it a bit too. So something like that will do pretty good. So for sure, these pine trees are harvestable nodes, but let's show that it's not going to work with the pickaxe because pickaxes only target mineable nodes. So let's go over here to this node, and you can see the wood trees. They don't do anything right now, but we can still harvest the rocks, of course. We can still pick up a tree that's on the ground or wood that's on the ground, but we have to be able to switch to a copper axe now if we want to actually harvest a tree. So the next thing we're going to want to add is going to be something like a hotbar where we can switch our different items out by pressing on buttons that will appear at the bottom of the screen. So I'm going to right click on the canvas layer. This is where we'll just set up all the UI stuff, and we'll add a child node. So let's start a new scene with file, new scene, go to user interface, and we will set up our hotbar at the bottom of the screen. So we can right click on the control node, add a child node, and let's try a grid container again. So this grid container, I want it to show at the bottom middle. So let's go to layout, and change layout mode from position to anchors and anchors preset to bottom middle, I think is what we want. Let's see, center bottom. So that's where our buttons are going to show up now. So we can right click, add a child node. So here we can try with a button. I'm not actually sure if we want texture button or button, but let's try normal buttons first. Okay, and we can set an icon here. So let's actually add in the copper axe icon, or copper axe copper.png. So we'll drag that in there and let's see. So yeah, okay, that should just work with a normal button. So we could duplicate this and add in, let's say like a hammer button, and duplicate that again, and we'll add in a pickaxe button. Now we want these to lay out horizontally. So let's click on grid container and make the columns 10, which means that until we have 10 buttons, it's not going to jump to a new line. And then we need to add a script where we can take the buttons and use it to equip a different item to the player based on which button we press. Let's also take the grid container first and take its size, and I'll make it 20 pixels, or I guess it goes to 24 as a minimum. And then we can recenter it at the bottom. So center bottom. I guess we'll just manually move it down here. So as long as you get it to the bottom middle of the screen, that should be good enough for right now. Okay, I'm gonna rename the control at the top. We'll call this Hotbar. Let's save the Hotbar scene into the UI folder. Then we'll attach a script to it. Hotbar.gd inherits from control, that's fine. And we'll save that as well. Okay, next I want to take each of these buttons and I want to rename them to be item buttons because they're going to have a item attached to them. So let's have item button 1, item button 2, item button 3. And let's attach a script to the item button. So I'll right click and attach a script, extends from button. And in these, we're going to have a item that is set to the button. When the button is pressed, we'll be able to set that item to the player if it is a equipable item type. So let's do export var item. And I'm actually going to create another class, which will just be item for the game. Since we already have equipable item.gd, but not every item you'd put on a hotbar would necessarily be equipable. A lot of games would have consumable items like a healing potion or something. So we can have a base class that all items build from, all items that can be put on a hotbar at least. So let's right click in resources and I'll do new script. This will extend from resource and we'll just do item.gd. And let's make sure that is out in items folder. So now equipable item is actually going to extend from item. We can pull this information, display name and texture out to item.gd. So class name item, and then I'll paste that in, display name and texture, because all items are going to have both of those. And because when you extend a class, you inherit all of its properties. So a equipable item is going to have the display name and texture because it is a item. So equipable item here extends item, and then we don't need this because those are already defined. Now, one thing I have noticed is that when you kind of restructure your classes like this, that sometimes the inspector doesn't automatically update for your classes and your existing resources. So I'm just going to restart the editor so we can see how it displays here after it recognizes the item class. So let's go to project, reload current project. Okay, now extend items and go down to copper pickaxe. Okay, and now you can see the fields are still there and they still have the same data, but now this information is actually coming from item as a class, not from equipable item. So we can still actually write new fields in equipable item if we need to. Just note that now these fields are coming from the item class. Okay, now what that allows us to do is go into the item button and we'll have an export var for the item in the slot here. So this is an item, and now it can take any type of item, not just an equipable item. And we're not going to need a ready or process function here. Let's make sure that all three of these item buttons have the same script. Or really, let's take item button and right click and save it as a scene in our project. And UI, of course, so we'll save that there. Now we can just take these two item buttons, and now we'll duplicate the item button. And now all three of these buttons are inheriting from the scene, which is better because now we can jump into the scene to edit all three of them at the same time. Okay, let's just quickly set up the textures again. So under art, let's get the tools. So hammer can be there, and the third one of pickaxe is there. But what we really want to be having here is a setter function on our item, where when we set that, we also update the icon automatically. And we can have that run in the editor using @tool annotation, just like we did before. So I'm going to jump into the item script. Let's go up here to the top. I'm going to do @tool. So now code is going to run in the editor as well. And let's create a setter function. So new item, or we can call it item to slot. That's going to be a type item, obviously. So when we set the item to slot, we need to update the member field. So like that, item equals item to slot. Okay, I guess we can't actually define that type there. And there's really no need to, because we know that when we're setting a value here, it's already an item. Okay, so what our button does have is a icon field. So we need to set that icon field to whatever the texture is from the new item. So icon equals item dot texture. Okay, and that is probably all we need right there. Let's test it out. So in item button here, let's go and get our items. So we have copper pickaxe and we have copper axe. So let's test with copper pickaxe here. I'm going to drop this into the item slot. Oh yeah, that's right. For the tool script to actually work, you have to reload the editor first. So let's go to project, reload current project. Okay, now we'll click on the button. Let's get the item copper pickaxe and drop it in there. Okay, and you see the icon updates immediately. So the second one, we'll click over here. We'll just drop copper axe here. Cool, that's updating the icon as well. We'll create a copper hammer item as well to go along with that. So duplicate copper axe, and I'm just going to call this copper hammer .tres. So let's click on copper hammer, and then we'll rename this copper hammer. For the affected types, right now it doesn't have any. I'll just delete the affected types. So the hammer can't actually affect anything yet. And the texture, let's load from the project in art, gathers exterior, tools, and we have copper hammer. Okay, so now that we have that item as a resource, we can drag this into the item slot, and the copper hammer is now showing up there. Next, we want to connect our hotbar to the player so that the hotbar can access the currently equipped item on the player and change it when one of these item buttons are pressed. So we set up a node group called player specifically for the player character, so we can use that in order to find and access our node. So let's jump into the hotbar script. So we're going to have up here at the top @onReadyVar player is of type player, and we're going to get that equal to get tree dot get first node in group, because there's only one player, single player game, and we're looking for the group player, and that should come back as a player node. Okay, so when we have the player node, then we can pretty easily get the hand equip node as a child of the player, which is where we put the equipped item. So let's check onReady if the player was actually found from onReady. And if that's the case, then we can do up here, var hand equip. I guess we can give it a class name too. So in hand equip, I'm going to give it a class name hand equip, or no underscore, hand equip. Now let's go back to the hotbar script. So our hand equip is of type hand equip. So if there's the player, then we're going to get the hand equipped under the player. So hand equip equals player dot find child, and we're looking for hand equip. So you can search by class name, and you can also search by the name of the node. So once we have the hand equip, we just need to know which item is being changed out on the player, and then we can set it up. So we don't need this process function here for sure. So next, when these item buttons are pressed, we need to have the item that they are storing equipped to the player if the item is of a type equipable item. So taking a look at the signals here, the signal for pressed doesn't actually specify which button was pressed, which is a little annoying. So I think as a workaround, what we'll do is we'll have the hotbar tell each of the buttons what the hand equip that's active on the hotbar is, and then each of those buttons can respond to their own signal, and we don't need to worry about which button was pressed because each button will respond to their own signal individually. So we need to get access to those buttons. So let's do @onReadyVar grid container, which is of type grid container. We're going to set that equal to grid container. So if we get the hand equip, then we're going to get all of these buttons under the grid container. So for button in, let's see, grid container dot get children, and then to easily see the field on those buttons and make sure that it's the right type of button, let's go into the item button class and let's give this a class name as well. So class name item button. So now we can check down here if button is item button, and then we can do button.item because we've already confirmed which class it is, so we have access to the fields. Really, you would have access to them anyway. It's just that they'll show up as a hint now that we're dealing with the class name. So button hand equip is equal to hand equip. So we'll need this field in the button as well. So we'll go into here. We'll have our hand equip of a type hand equip, of course. And that's how we let each of the buttons know about the dependency hand equip when our script starts so that they know where to put the item and they also have the item to put. So now we just need to connect each of these buttons to their own signal. One way we could do that is with function underscore ready, and we'll just connect the pressed signal to onPressed to a new function we're about to create, onPressed. Okay, and just to be consistent with naming schemes, underscore. Okay, let's create that function now. Function onPressed underscore onPressed. So the first thing we're going to want to check is if the item is a equipable item. So if item is equipable item, then we also want to check if the hand equip is valid. If hand equip does not equal null, then we're going to take the hand equip and we're going to set the item that's equipped to the item. So hand equip dot equipped item equals item. I renamed equipable item to have only one P. So that should fix that up. Okay, so our buttons will now respond to their own signals, and we can put the item in the hand equip slot. The hotbar will take care of finding the player and finding the hand equip slot. Reason to do it like this rather than on each button is you might have 10 buttons, but just finding the player once and telling the different buttons about where the player is or where the hand equip is just a bit more efficient way of doing things. So let's go back to our game level scene, 2D view, and let's put the hotbar under the canvas layer. So hotbar in the file system, drag the scene here. Okay, we can see it down there in our UI. Let's hit play, and we have our hotbar down here. Let's test it. So I'll click here, and we change our equipped item. Click here for the hammer, here for the pickaxe, and just like that, we have a hotbar, which will work for switching out tools. So if we switch to the pickaxe, we can harvest this node and get all of that stone. But if I switch to the hammer, you can see this tool doesn't actually work for that, and neither does the axe yet. Oh, but the axe might be able to harvest the tree now. Okay, there we go. Yeah, we're harvesting the tree. Got all of that wood. And of course, you'll notice here that when we're harvesting these trees, we don't have to use the swing animation yet. So we'll set that up in a minute so that you only harvest during the swing animation. But you can see how our different tools are now harvesting different nodes, which is super cool. And we can just switch between our hotbar tools with just one button press. So one last thing before we wrap up with our item button script here. Since we're using the @tool annotation in order to make it so that we can set the item texture in the editor whenever we update the item, but adding @tool also means that other code may actually run in the editor as well. Now I'm not totally sure if underscore ready or the callback on pressed are going to trigger in the editor, but we want to make sure that they don't, I think. So let's add the bit in to make sure that it will only run in the actual game, despite us having the @tool annotation. So if we do if engine.isEditor hint, then that means that the code that follows is going to run in the editor. So we want if not engine.isEditor hint. And then on the next line, add the tab. So we save that. So this means basically any code that comes after here, we're going to skip when we're in the editor, but we are going to run in the game. And we want to put the same thing down here on pressed. So when you're using @tool, although it's cool to be able to run code in the editor, you do have to be careful when you're combining it with your actual in-game code. So let's still make sure that the buttons still work. So if we go in-game, we can see that they do. but this should now prevent us from accidentally pressing on the button and setting the hand equip to the player when we're just editing the game here, because that could kind of mess things up, and we don't want that to actually trigger. So be careful with your at tool, and then use these lines when you want to separate your editor code from your in-game code. One more thing for this little hotbar. Let's move it off of the bottom of the screen by about 5-10 pixels, kind of like we did up here. So I'll close out here. Let's go into the hotbar scene, and let's, we could add a margin container, which would work all right. Or we could just take the grid container and let's hit W to go into move mode and just move it up 10 pixels. I think that will basically achieve the same thing here. So I'll save, we hit play to go into game mode, and now it's up there. But it scales everything by ×4. I forgot about that. So let's actually move it to more like 2 or 3 pixels off the bottom. So moving it 7 pixels down means it's 3 off the bottom. So ×4 is going to mean 12 pixels off the bottom of the screen. So that looks like a pretty good placement for our hotbar. And that should pretty much be it for what we need the hotbar to do. So next up, one of the things that has been around for a while that we, of course, need to fix is that we can harvest nodes just by running into them. That's simply because our area which is harvesting the nodes is active even when we are not in the swing animation like this. So we just need to make sure that we enable those areas during swing animations and disable it at all other times. So let's go to the player scene, and we'll take a look at the animation player, and we'll also take a look at the area 2D. While we're here, I've also noticed that there's been this update cache bug in the error log. That's just mentioning that these properties are set to continuous when they should be discrete. For this pixel art game, all properties are going to be discrete, which just means that they only update when you hit a keyframe and not try to change the values in between keyframes. But anyway, let's go to swing down animation, and we can see that we don't have any mention of the area 2D set up here yet. So we're going to have to add a track. So let's do a property track on the area 2D, and we're going to be looking for monitoring, and we're going to turn that off at all frames except the last one where our tool should be hitting whatever node we're trying to harvest. So we can right click here and insert a key for monitoring to be on, but at the start here, monitoring should be off. So I'm going to disable that. So you right click, insert a key, and then toggle the Boolean off. And then at the end of our animation right here, I also want to insert a key and toggle monitoring off again. So basically we enter the animation, monitoring is going to be off. We turn it on for 1 frame, that's 0.2 seconds. And then we turn it off again as we exit out to other animations. So just to double check that that's kind of how it's going to work here, let's look at the hand equip script. And we can see on area body entered 2D. That's when we're doing the interact with body function, basically harvesting the nodes. And that means that we need monitoring to be on for that to work. So that we don't have to mess with the monitoring settings on every single animation, we'll just have the other swings set up exactly like this, and we'll have monitoring turn off automatically on ready. So let's create the function underscore ready, and we're going to take the area 2D, which we have to get access to with on ready var. So at on ready var area 2D, and we'll look for area 2D in the list of nodes. So it'll just jump down 1 node, find that area 2D, and assign it. So after we have area 2D, we want to on ready do area 2D.monitoring, and we'll set that to false. Now to note, at tool annotation is in the script, which means that our code will run in the editor. I want to make sure that our code that isn't the setter function here does not automatically do that, just because it might cause some problems down the road. Like, it would probably be fine for monitoring to turn off automatically when our script loads, but let's just make it so it doesn't. It only needs to do that when the game loads. So I'm going to do if engine.isEditorHint, and we want to inverse that because we don't want this code to run in the editor. So it's if not engine.editorIsHint, then we'll run our onReady code. So now it's only going to run in the actual game. And let's do the same thing down here. So if not engine is editor hint, tab this over 1 bit. Okay, and now the only code that's going to run in the editor is this, and all of this is now game specific code. So just be careful when you're using the at tool annotation, because once again, it makes the code run both in the editor and in game. So it can be a little dangerous. having your properties change in the editor if you aren't careful. Okay, anyway, let's go back to the other animations, and we just need to repeat this area 2D monitoring. So let's go to swing left, add track, property track, area 2D, monitoring. Okay, and just the same at the start, we come down here, right click, insert key. So monitoring's off, go to 0.4 seconds, insert key, monitoring, toggle it on. And then at the end, 0.6 seconds, turn off monitoring once again. I think we might actually be able to just select all of these keyframe points with a box select, Control C. And now we go over to swing right, add a track, property track, area 2D, monitoring, and let's see if we can paste it in here. Nope, that doesn't work. Okay, so we'll right click, insert key, monitoring off at the start, on at 0.4 seconds, and then off again at 0.6 seconds. Okay, and lastly, we'll do swing up, same thing, add property track, area 2D, monitoring. Okay, come down here, right click, insert key, turn it off, 0.4 seconds, right click, insert key, turn it on, and 0.6 seconds, right click, insert key, turn it off. Okay, so now monitoring will turn off at the start of our script when the player enters the scene, and it will be turned on only at the 0.4 second of our swing down, left, right, up animations. So with that, we should be able to hit play. And if we run into this rock, the tall rock, it's not going to harvest anymore because monitoring is off. But if we swing at it like this, you can see that the harvesting actually works again. So that's basically all we need to do to make sure that the harvesting works as intended, and we actually need those harvesting animations to harvest these resources like the tree. So let's run into here and start harvesting the tree by swinging the axe, and it is pretty much working as expected. So at this point, we already have a pretty solid foundation to the game, but there's still more things we could add in here. For instance, we could add in a particle effect. When our nodes here vanish because they've been harvested, we could have an explosion of pixels to come out when our nodes are removed from the scene. So let's create a pixel effect next. I'm going to go to scene, new scene, and let's look for other node. We want particles. So we can use either CPU or GPU particles. Personally, I don't know the ins and outs about how these exactly compare, but I think on the documentation they do mention that when you have a ton of particles, the GPU particle system can outperform the CPU particles. But more or less, they have about the same properties you can set up in the inspector. I think GPU particles has subparticle rendering, but I'm not sure that CPU particles does. Anyway, we'll just go with GPU particles. I don't see a good reason not to. So we'll use that for our particle system. We'll rename this particle system to be something like depleted resources explosion. Okay, if we hover over this little warning, we'll see that we need a material to process the particles is not assigned. So basically we need a texture. What are we going to actually show for our particles as the effect? So if we want to keep it simple, we can just click here and do I think new canvas texture was what I was trying to go with. Yep, and that just gives us like this little square. If you want to change the color of a canvas texture particle, you can go down to visibility and self-modulate to change this color. If you do modulate, it changes the color of all child nodes as well. But we could change the color here to something else like red or blue if we wanted to, but I think just white pixels will do just fine for right now. Okay, so if we hover over the warning, you'll see that in order for the GPU particles to do anything, we need to have a process material, which we can assign over in inspector process material. So here we want new particle process material. When we do that, you'll start seeing the particle system actually starts to do things. If you want to edit the properties, just click on that and you'll get a whole bunch we can change. So one we're going to turn off is the gravity. So if we click on gravity, we can change the Y gravity to 0. And now that's going to stop the movement. So then we need to figure out from our origin point, how do we want this particle effect to look? Where do we want the particles to come out? Should it just be an explosion and like a ring that goes all the way around? Should the particles come down in an arc? So there's many ways you can set that up. So if you want to control where your particles spawn from, you can click on shape and change it to something like a sphere or a ring or a box. If you want the particles to randomly spawn away from the center point, but more inside of another shape like a sphere, a box would, of course, just be like a rectangle, and a ring would be like a sphere again, but with the center part cut out. So you could think of that like a donut. But for right now, I'm going to leave it as point. We'll just see if we can have all of the particles start from the center and then go out in the directions we need to. So that means we're going to need to set the velocity. We can start with initial velocity. Let's try setting it to something like 50 velocity min, 50 velocity max. Now you can see it's coming out of here in like a 45-degree arc. That's because if we look at direction, the spread is 45. So if we wanted this to be a full circle in the direction of the velocity, then we can change the spread to 360 because a circle has 360 degrees. So now it's coming out in all directions. But right now, you can also see that it is coming as a stream, but you might prefer for this to be more of like a burst effect. If we're dealing with an explosion, that would more be like all the particles coming out at once. So if we want all of the particles to come out at once, then we need to find I think it's called explosiveness. So I'll filter properties because I'm actually not sure where that is. So I'll type up here explosiveness. So that's in time, I guess. And we'll take the explosiveness and let's set that to 1. So now you can see that everything comes out at once. So more of an explosion. And we can take the amount and increase that as well. So if we do something like 20, then we're going to get a lot more particles coming out. Let's try 30 even. It really won't matter if we're just emitting 1 pixel particles like this. I doubt any machine can't handle that. So it's not very complex or anything. So if you wanted, you could probably do something like 3000 and get away with it. So now we have almost like a complete ring being emitted, which is actually quite cool, honestly. Maybe a little bit too overkill for what we're dealing with. Let's try 300 and maybe 150 because I do want there to be some gaps here. And I don't actually want these particles to come out as far as well. So rather than slowing the velocity, let's decrease the lifespan of these particles. I'll come down here to time section. I guess that's where explosiveness was. And let's change the lifespan to 0.25. Okay, that's a little too short. Let's do 0.5 instead. Okay, so the only way we can really test this for sure to know how it's going to look would be to put it inside of our actual scene. So let's Control S. So I'll create a folder for particle effects and the like here. I'll just call it effects and then save it in there. Now let's go to the game level scene and I'll take the particle effect from the effects folder and let's just drag it in here to where we have our node. And this will be roughly how the particle effect compares to the size of the node. I think the particles could stand to be a little bit bigger than that. Let's hit play and test to make sure that that's how it looks in game as well. All right. And I'm going to take this effect and jump into it. So let's first off increase the size of these particles. So let's go to scale, and for scale, maybe we do 2 and 2, and then let's shrink the number of particles to 50. And maybe I want to lower the velocity a little bit as well. Or rather, we can keep the initial velocity as 50, but let's actually slow that down over time. So I think with damping, that's might be what you need. Let's try 1 and 1 here. Okay, it does seem to kind of do it. Let's try changing it to 10, 10, 30, 30. Okay, yeah, and that definitely does seem to be slowing the particles over time. So 50, 50. Okay, I think I'm liking that a lot more. So we have particles that start off fast and they get slower over time. We can also make it so that these particles fade out at the end rather than just disappearing from view all together at once. So for that, we would need to go to color and then we can make I think it's a color ramp we want here. So let's do a new gradient texture 1D, and this will be the color over time. So if we click here, we can edit the gradient. We want to start with white, of course. So I'll change that initial color to white. And let's click here to add another point for our gradient. So this will be about the time during our timeline duration where we start to fade out the color. And then this final one, we'll double click on it and let's lower the alpha to 0. Okay, so now what happens is at the end, you can see that our particles actually fade for a second before they just disappear from view. So it should be a little bit of a smoother transition out. And we can test it by saving and hitting play, taking a look at our game scene. And that will be roughly how our particles look after we harvest a node. Of course, we're only going to have it emit once, and we only want it to happen once the node is destroyed. But we're getting pretty close. Let's take the scale, and I'll increase the size to 3 here for the particles. Oh, let's make it a range actually between 2 and 3. So I have a little bit of variation between our particle sizes there. And let's take the amount down to 40. Okay, just want it to look a little bit chunkier, a little bit more pixel art. And lastly, we can turn off emitting. So what we'll actually do is we'll spawn our particle effect. We'll emit the particles one time, as a burst, and then we will basically remove the node once all the particles are gone. So to automatically remove our particle system from the scene, I'll right-click Add a Child Node. Let's look for Timer. We'll say 0.5 seconds to remove it. And then let's attach a script to our depleted resources explosion. So I'll create this new script here, and then we're going to need a callback from the timer. So the timer, go to node, click on the signal timeout, connect it to the depleted resources explosion, and then on timeout, we're going to queue free on the particle system. So we just need to make sure that the duration for our particles being there is less than the timeout for the timer, so that the particles can all finish their simulation. But remember, we set the time to 0.5 seconds. So after 0.5 seconds, the effect should be able to remove itself without any problems. If you want, you can make it a little longer just in case, and do something like 0.55, give it a little extra time. Let's also turn on one shot and auto start, so this will happen automatically. Okay, and now we just need to create our depleted resources explosion at the location where our resource node is removing itself, and then emit the particles when that event occurs. So let's go to resource node Pine. Let's open up the script here, and we're going to have an export var for the particle effect we want to spawn after the node is depleted. So we can do something like under pickup type, let's say at export var depleted effect, which will be a type of GPU particles 2D, and we'll save that. Okay, so now in the inspector, we can assign our effect. So I'll just drag and drop it, depleted resources explosion.tscn, into the slot here. Oh, I messed up. Because it's not in the level yet, it's actually a packed scene. You have to instantiate the packed scene, and then it's a GPU particles effect. Okay, so in the inspector, we drag the packed scene into the slot, and then we instantiate a copy of that packed scene. So then we go down here to where we queue free. Before we queue free, we want to spawn particle effect before removing the node. And then we'll create the effect and add it to the level parent. So let's create a local var here. So I'll call it effect instance, which will be a type of GPU particles 2D. And we're going to create that by taking the depleted effect and instantiating that. Okay, after we instantiate it, we add the location of it to be the location of our resource node. So let me take a look at the effect scene. Does this have a position we can set, a transform? Yeah, okay, so transform position, we should be able to set that. So in our resource node script, once again, effect instance dot, let's see, I think we could just say dot position. I'm not sure why it doesn't show up there as an option. But anyway, this will be equal to the position of this node, but we add it as a child to the level parent. So level parent dot add child effect instance. And this means we create a copy of the effect, we position it at the node, we make it parented under the level so that when we remove this depleted node, it doesn't remove the particle effect. Also, we want the particle effect to last after the node has been removed. And then we just need to emit some particles on the effect instance. So effect instance.emit. I'm not sure why the functions here aren't showing up as an option. But just to be sure about the function names, we can search help up here and do GPU particles 2D. Come down here and look at the functions. I guess GPU particles doesn't actually have an emit function. Not a problem. So what we'll do is we'll just make sure that by default it is enabled, and then we'll just make sure the emission only happens once during that 0.55 seconds. So maybe we have the loop be 1 second, but the particle system removes itself after 0.55 seconds, so it'll only ever emit once anyway. So let's open up the depleted resource node scene, and we'll toggle emitting on. And oh, actually, the one shot here, that's what we want. So we just do a one shot, and when emitting is done, then it's just going to turn itself off automatically. So that's actually pretty much perfect for what we need there. All right, so that might actually be everything we need, just these 3 lines of code. Let's make sure that the rock also has it. So we'll filter files, resource node, resource underscore node, and we'll change rock tall to use that same effect. So we can load a effect from our effects folder, and we'll do depleted resources explosion. Okay, so now they both have that same effect. Let's test it. Let's go to 2D level and make sure that the test depleted resources explosion is removed from the scene. That shouldn't be there by default. It's only going to happen after one of our resource nodes finishes, and then we'll have the explosion. So let's hit play. We'll go harvest this rock. 1, 2, 3, 4, 5. And we didn't actually get the emission to occur. Okay, so we'll have to figure out why that is. Let's try editing the depleted scene first and see if anything is going on here. So emitting is actually off by default now. So maybe actually we just need to turn emitting on since the one shot occurs and stops in the editor, I guess. So script view, and we're going down and looking for a resource node. And then for the instance, the effect instance, we're going to take emitting and turn that to true. So let's see. Emitting equals true. Okay, let's try that. I'll turn off this breakpoint. We'll hit play. We go here and harvest the node. 1, 2, 3, 4, 5. And we get our explosion. Sweet. So let's make sure that is also working with the tree. 1, 2, 3, 4, 5. And we get our explosion. So now we can just basically tweak our effect to what we need it to do. But our particle system is basically working there, which is pretty cool. So a couple things I might change, increasing the size of the scale. So let's try 4 and 5. And let's also increase the initial velocity a bit more to 60, 60. And I'll test it one more time. Let's go harvest a node. 1, 2, 3, 4, 5. And there's our explosion. So that'll do pretty good for right now. So at this point, we have a pretty functional resource gathering system for our game. We can harvest nodes. When the nodes are depleted, they'll explode with a particle effect. We can switch to different tools with our hotbar, swing at a different node, and only an appropriate tool will be able to harvest the right node. So I think just to kind of wrap up for fun, we could try to expand our game level a little bit, add a few extra types of nodes and different terrain that we can walk on. And that'll pretty much be it for this mini-series on creating a Gatherer RPG. So one thing that would be pretty cool to add to our game to make the world a little bit more lively would be animated tiles. So we can add a bobbing raft that we can walk across to get between our aisles using the textures that are in the Gatherer's exterior pack. So here I have floating platform.png. So in order to add the raft, I would drag this into the tiles section for the tiles set. So if you don't remember, you just make sure you have Tilemap selected, go to tile set view, and it will be right here. So drag this over here. And when you get, would you like to create tiles automatically? This time hit no, because we're going to be creating just one tile, but it's going to be animated. So now go to setup view, make sure that your texture region is set to be the size of your tiles. So 16 by 16 is what I need here. So I'm just going to left click on the first tile. And rather than creating the other tiles here, what I'm going to do is go to select mode, select my tile, and then animation frames, we want to click add element. And the next tile will be automatically added as part of this one's animation. So do that 2 more times for a 4-frame animation. And we want to set the duration for these frames for how long each of them should take. So I'm thinking something like 0.2 seconds should be good. So 0.2, and then tap a few times 0.2, so on and so forth, 0.2, 0.2. So that'll make a 0.8 second long animation to draw with this animated tile. Okay, so now let's go over to tile map mode. Make sure eraser is turned off, and make sure that you're in selection mode so you can hit Q for that. And I'm going to be writing these onto the top layer so that it doesn't override any of the ground. So top, and I can just basically place the rafts where I need it. So like so. And you can see that already in the editor that our raft is animating. Now it's moving a little fast. So I'll go back to tile set view, click on the tile editor, and then go to the frames. Let's make it 0.3 seconds for each of these. You can, of course, have different timing for each frames if you want. But that's how you can take a animated sprite sheet and turn it into a tile animation for your editor. So let's create a couple more rafts that will lead to more islands, kind of like so. Now, the way that I had the collision set up for the water was that all the tiles that are water have collisions, except for the ones, if we go to water view here and tile set water, that are using the alternative tile. So I'm going to draw the alternative tile under these rafts so that I can actually walk under them. So let's do that for all of these water tiles. Okay, and then save the game level, and let's hit play to test. And we should be able to walk onto our rafts, as you can see here. So this one, I must have missed a tile, but let's keep going and check out this over here. We can get onto that island. So let's stop the view and finish up that collision change for the water. And if we go back into play mode, actually, what's causing the block here is the ground tile itself. But because the water tile already has the collisions, I can actually just remove the collision from this ground here because it's the water that we really need for the collisions. So let's go back out. I'll edit my tile set. Let's go to tile set grass. And these tiles here, these three that already had their physics layer set up, we'll just remove the collision shape here. So if we hit C to clear, we can left click on each of these, C, clear, and that should just remove the collisions from those. So now if we hit play, again, we'll go down to here, and you can see that the water under it is still blocking our movement. But if I go here, where we don't have that water collision tile, but just a normal water tile, then we can actually walk and exit our island. So just a little bit of tweaking to get that needed, and now we can basically walk over the water where we need to. So just to add some extra tiles and for fun, let's do the decor grass tile set, drag that in here. We'll automatically create tiles for this, and then we can just draw some tiles where we need them to be. So on Tilemap, I will do this on the top layer so that we can draw onto the grass. We can actually select all of these tiles if we want. And then let's go to random mode and then just left click where we want to have some random doodads show up in our game world. So just an easy way to add in some more detail. Now let's add in another terrain. So I'll have tile set desert. We have to be in tile set view for that. So drag tile set desert into here, automatically create the tiles. And basically we just kind of repeat the steps. So we'll take these tiles and we'll draw whatever island shape we want. So I can do something like this here. Then we'll have the edge tiles where we need them to be. So let's get all of those going. These tiles are pretty simple to use, so it should be quite straightforward. Just kind of where there's an edge, then it should show an edge, and that's pretty much it. So let's do the top bit here. So corner, corner, and then the edge tiles. So then we might also want to place some additional objects into the game world over here. To kind of organize our game level, let's right click and I will add a child node. Let's do a node 2D. I'll rename this to be world objects. Okay, and then let's just drag all these resource nodes into there, world objects. Okay, and now if we need to, we can minimize this menu so that we can see the important stuff in our game level. So let's add a cactus to our desert, and I'm going to save this cactus as another scene. Let's go to objects, and I'll just create a folder. I'll call this doodads. So this will just be for objects that aren't placed by the tile map, but also aren't necessarily harvestable. So, okay. Then we could just call it cactus 1, I guess. Let's jump into the scene, and I'll right click on it, add a collision shape. Let's look for body, static body 2D. Right click on it, add a child node. So we need a collision collider. So a collision shape 2D. We'll click on shape, and let's do a capsule shape. Just make it make sense for the object we're creating a collision for. Remember that the top bit is kind of above the ground, so we only need to create the collision where the object touches the ground with this top-down perspective. So we can save that. Go to our game level. We can see that this still has a collision shape, so we can duplicate it and move the duplicate over here. We can also go into the doodads folder and duplicate the cactus for, let's say, cactus 2, and jump into cactus 2. So we just need to change the texture out. So let's load from art, gathers exterior, objects, desert, and we'll have cactus 2. Okay, now we can go back into the game level, and then we can drag a cactus 2 into the scene. Now make sure that in these scenes, you actually reset the transform to 0, 0. So when we're placing the nodes, they should be wherever our cursor is centered. So rename that there, and we can also call the node cactus type 2 if we want. Go into cactus 1, change the transform of the base node to 0, 0 here as well. Then I'll rename the node cactus underscore type 2. Sure. Let's go to the game level, and now let's make sure that our cactus nodes get placed correctly. So I'm going to drag this one down here, and then we can drag a cactus type 2 into the scene as well. Okay, maybe next we want to use the desert tree. So let's create a desert tree that we can use as a resource node by duplicating our resource node tree pine. So I'll duplicate that, and let's just call it tree desert. We'll jump into that. Maybe the tree desert has a starting resources of 7. We'll leave the pickup type of the wood the same. It's still a tree. Maybe we could change the color of the wood to represent a different type of wood. And the depleted effect, everything else would basically be the same. Just got to look at our node here and change the sprite, really. So for sprite 2D, we're going to load. Let's go into art, gathers exterior, objects, desert, and then let's grab the savanna tree. I'll rename this up here to be savanna tree, and maybe we'll also call the scene file tree desert savanna. Just being a little bit more specific there. Okay, and the collision shape, let's expand that, make it a little bigger. This tree is bigger, so we want it to be kind of centered there. Okay, and then basically we can just go to the game level, and we can bring in this tree, kind of like so. And let's bring in a couple of them. Oh, the last thing that we might actually want to change as well, the center point here, that's the position that it's going to use for the explosion. So we may actually want to come in here and edit it. We can move the sprite up a bit. So the sprite 2D, I'll hit W to go into move mode. Let's move that up. So the center point is the actual location of the tree. So I kind of want the base of the tree to be centered there. And then let's move the collision shape up there to the center as well. So now if we check game view, that's going to update the positions a little bit for our nodes. So let's adjust those. And tree 2, tree 3, okay, tree 2, something like that. Okay, now let's hit play. We can go down there and we can harvest from our trees. Okay, a couple cleanup things. Let's also take these resource nodes and move them into world objects. Also take the cactuses and move them inside of that as well. And I can close the world objects menu. We really only need to drag and drop stuff into that. And then lastly, on the tile map for tile map, if we look at the water layer, there's still water under here. And because of the way everything's set up, we actually want to remove those water nodes. So let's use the erase tool, and we can use pencil mode, hit Q. Actually, let's use the rect mode. It'll be quicker. And then just drag a box here to remove the water tiles under there and there as well. So that'll make it so that we can actually walk on this ground. If we hit play, now we can go down, walk onto our island. We'll switch to the axe and we can harvest our tree. 3, 4, 5, 6, 7. Okay. Yep. And this one as well. 1, 2, 3, 4, 5, 6, 7. Okay, another thing that's kind of going on here, the hotbars ended up below the screen. So if we go out, take a look at our game level, we can see that's the case here. Our hotbar is showing off center by a bit. So if we look at layout and transform, we should be able to reset this transform like so. And to make sure that we don't accidentally mess with the transform here, I must have used the move tool on this hotbar node. Let's take the hotbar node and let's lock it into place here. I'll also take the resource display and lock it as well. Just make sure that we don't mess with those, the positions on them. So if we hit play, we can go back to our main game view and we can see that the position is corrected for that. So we can still like switch to, you know, the different tools and use them on our trees, just like we would have expected before. Gather all the resources. So here we can see one issue I created, which is that we need to make sure that the world objects actually can sort based on their Y position. Let's see if we can test that out in the editor right now by going to Remote View, Expand to World, Objects, and then let's go down here to Y sort enabled. I'll check that. And now if we go back to the scene view, you can see that our character can once again sort based on the Y position. So that means in the actual editor, when the game stopped, we just need to take world objects, go to ordering, and check Y sort enabled. So that will make all of the child objects also sort based on the Y sort, just like the game level already had set up. So just for fun, I'm going to add in another biome over here to the left. So let's go to Tilemap view. Let's see if I can find the dark sprite sheet right here. So tile set dark, I'll drag that into tile set view, automatically create the tiles. Okay, that's done. Now we can go to Tilemap. On the ground, we want to come over here and just gonna lock the position of the Tilemap as well. Yeah, okay. So ground view, Q for selection mode, turn off eraser tool, and I'll do rect select so I can draw some ground easily here. And then let's do the side tiles. Okay, zooming in a bit might help actually. Then we have the bottom tiles and lastly the top. Okay, and these little corner pieces too. Okay, so that pretty much looks good. So now let's add another type of harvestable tree. I'll duplicate the pine and let's do tree dark. Let's open up that scene. We'll change the sprite node here to be something else. So we'll load from the project and art gathers exterior objects dark. And let's grab a tree here. Suppose we could just use the kind of bushy berry-like tree, and the collision shape is probably okay as it is. To make things a little bit more interesting, rather than just harvesting normal wood, let's make a dark wood. So not in resources types, but in pickups, let's duplicate the pickup brown wood to be pickup wood dark. So we'll double click into that, and then let's change the icon here. So I'm going to load art gathers exterior. Let's see, resources, wood gray. And then for pickup wood, we need to change the resource type. So we had that in items, resources, resource wood. So we'll duplicate the resource and we're going to call it resource wood dark. And we can double click in that resource and we change the display name to dark wood. We'll change the texture to, let's load that same texture file. So resources, wood gray, and I'll change the resource name down here to be dark wood. Okay, so now in pickup wood, we just need to set the resource wood dark as the actual pickup item. Okay, and now we go back to this dark tree. I'm gonna rename it. We'll call it dark tree. But actually, in this scene, I can see that I edited the wrong one. This is the tree pine. So I'm gonna actually don't save this scene, and we're gonna repeat that step with the tree dark. Okay, so basically here we just changed the pickup type. So let's load a pickup type from the project. That would be in objects, pickups, dark wood. Okay, and then the node is going to be called dark tree, and the sprite is going to use the dark tree sprite. So art gathers exterior objects, dark tree small. Okay, now we can save that. Let's take a look at the scene here and make sure that the pickup is the right scene. So I'm going to open that scene. Okay, and that is the dark wood. Okay, now we can go to the game level, and I'm going to place a couple of these dark trees, and let's just pop them in there, kind of like so. I'll move them all under world objects. Let's finish the bridge here. So in Tilemap, floating platform, we'll add these to the top layer. So make sure we're in pencil mode, turn off random again, and then add those rafts so we can get over there. Then we need to change the water and just remove the collisions. So water tiles, use the alternate tile, and then just paint over the spaces where we should be able to walk. And now we can hit play. We'll be able to walk over here to the dark island. And also don't forget to remove the water tiles under the island, or you could change them to the walkable water if you want. It probably doesn't matter actually. So if you want to use walkable water, we could just drag this for the size and shape of the island like so. You'll never be able to see it, so it won't make a difference here. And then now we should be able to walk onto the island like so. and harvest our tree. And you can see this is giving us now a different type of resource. This is the dark wood, which is different from the normal wood we get over here. So you can see those are adding different inventory slots. Then we have our stone as a third option. And if we want to make the dark island a little bit more interesting, we can add in the decor tile set into this. And make sure you're in tile set view, decor, yes, automatically create. And let's draw some of these decor tiles onto here on the top layer. So can place some flowers, some mushrooms, some random sparkle dots, maybe a summoning circle, and some colorful flowers, and basically call it good. So we can, of course, walk onto that island and see the cosmetic changes there. Okay, so pretty much in a nutshell, that is just about it for setting up the basics of a resource gathering game inside of the Godot engine. If we want to go through everything one more time, we have our main character who can swing a pickaxe, of course, harvest some resources. You can change which tool is equipped to his hand, and of course the animations update with that correspondingly. So we can keep harvesting different types of resources. Different tools are used for different resource nodes. So, okay, well, that's a tree, but this is a stone, so our axe cannot harvest it. We can walk across bridges, go to different islands. In the top left, we have our resource counter. So these are the resources that we added to our character's inventory. And if we come down here, we can get a different type of wood. So we have 3 resources. And of course, as you've been seeing, whenever we finish harvesting a tree, like so, or a rock, we get that particle resource explosion. So that is pretty much going to be it for this tutorial on creating a resource gathering RPG inside of the Godot engine. I hope if you watched from beginning to end, you learned a heck of a lot about the Godot engine and how to set everything up inside of it. So I've been Chris. That's going to be it for this video series. Thanks for watching to the end, and I will see all of you in my future game development content.